Okay, my clock says that it's time. So let's get started. Welcome to the third day of the workshop. Today's sessions are themed as synthesis. And after starting the conversation with rather bleak perspective of how we still haven't figured out how to measure quality of the internet, and that maybe the previous attempts were futile. And after exploring different angles of where the quality may be and how to measure it, today we are going to look into concrete suggestions by several participants on how to start measuring network quality today in a way that would be meaningful for the end users. This may not be the final metric to measure it once and for all, but we hope that it will be useful in the following years, useful to make the experience of the end users better. We hopefully by after hearing all the presentations yesterday, the first day, everyone now has rich context so that we can continue with the fruitful and productive discussions. And since the theme is synthesis and not competition, we're not looking to pick the one method that is better than others, but rather maybe to consider how those different methods may support each other and coexist. So let me, I don't have much more to say. Well, actually I do. Logistically, this day will be slightly different from previous 2 days. We will have 2 sessions and not 4. And the last part of the last 2 hours of the workshop, after the break, we will be doing a short recap, and we will start discussion of what would be the next steps that we should take.
We have 3 sessions with 1 hour at the end, I think.
Do we? Okay.
Yep, but you're right otherwise.
All right. Well, thank you. We have 3 sessions, and we have we are going to finish with a recap. Thanks, Wes. So before I make any more blunders, let me give the mic to Randall, who is going to be driving today's first 2 sessions. Thank you.
We had one more comment. At the end of the day, during that discussion, we will be trying to figure out sort of next steps and conclusions that we think that we could make, as a whole. So as you're thinking about through the day, do start thinking about where do we go from here, so that we can get an out from the workshop that might have a forward direction of next steps.
And the last reminder, let's try to utilize Slack as we did for the in-depth discussions, and leave the WebEx chat as the control plane, so that our moderators will have easier time recognizing who's in queue and whom to call up next. Thank you, and now I'm really out.
Hi, can you all see the slides? Okay. Here's our agenda. Oh, first, I'm Randall Meyer. I'll be your chair. This is my first time, so please bear with me. Here's our agenda, and we will start with Sylvester.
Yeah,
Sorry.
you can pronounce it like
Okay.
Yes. Okay, hello everyone. I'm presenting our work on incentive-based traffic management and quality of service measurements, work of several people. Please go to next slide. So what is traffic management? Traffic management consists of mechanisms controlling the congestion, and they can be in a way sorted by congestion duration from short to long. So for example, if you want to have very small delay for your packets, that's packets are short congestion, so you can solve that by AQM and scheduling. If you want to decrease the load on your network, for example, in the busy hour, you might need to change your uses policy and service level agreements, and there are all these algorithms in between, like resource sharing, congestion control, content adaptation, maybe also load balancing and admission control. You need to dimension your network somehow. And if you want to solve a problem, it's wise to choose the right mechanisms depending on the congestion duration. So again, it's unlikely that you can, for example, solve your packet delay by changing the usage policy, even though there are solutions for that. And for each mechanism there are alternate algorithms. For example, if you take congestion control, there are different TCP congestion control algorithms. And we believe that traffic management can be grouped into strategies, and we define strategies as harmonized set of algorithms where there is one, more, or zero for each such mechanism, 1, 0 or more algorithm for each such mechanism. For example, best effort internet access is such a strategy, even though there is minimal harmonization among the algorithms. And in general, updating a single algorithm has limited impact. If you want to reach something, consider also updating the strategy. And also an update might even break the harmonization of strategies. If you introduce a new TCP CCA and the new AQM, the two might have different assumptions and might break the strategy itself. And our question is that, is it possible to have a strategy for the internet with richer SLA and more meaningful measurements? And where is the place of measurement in this? And how does it cooperate with the rest of the algorithms? Please go to next slide. So as an example, we take the incentive-based core stateless quality of service strategy. It's called per packet value. You can find much more information about it in a homepage. And again, this is an example for such a strategy where resource sharing policies are expressed something called throughput value functions. You can see such throughput value function examples on the right. And that function you can encode by marking a packet value on each and every packet. Different flows may have the same policy, which means the same function, but separate marker, or they can have different policies. And in this strategy, scheduling an AQM works only by maximizing the transmitted value. There is no need for flow identification or policy knowledge of the bottleneck. And in this strategy, we have something we call congestion threshold value, which is a rich congestion measure. You can see on the right-hand slide that the intersection of the throughput value functions and the congestion threshold value defines the desired resource sharing for each and every flow. This congestion threshold value is emergent of the scheduling, so you don't have to pre-calculate it. You can just maximize your transmitted packet value, and thereby you will have a congestion threshold value. And packets with higher value are dropped, lower value are paused. And this congestion threshold value may help in harmonizing the algorithms of traffic management. So for example, it can be used for load balancing. If you have two alternate paths, you can change the traffic flow until the congestion threshold value on the two paths will be the same. And thereby you will achieve an optimum. You will see these two paths as a single path. But it can be used for network dimensioning. You can have targets for different situations. And if the end user is doing the packet marking, it can also be measured by the end user. Okay, please go to next slide. So in conclusion, we argue that meaningful quality of service measurement should be supported by the traffic management strategy itself, and the measurement shall be considered during the design of the algorithm. Maybe it should be part of the strategy, the measurement itself, but we highlight that usage policy is also is a very important among the mechanisms to be harmonized with the measurements. And we believe that using a rich congestion measure for both the measurements and for harmonizing the algorithms of traffic management strategy looks a very promising way forward. Take the example on the previous slide. At the same time, the simplicity of the internet and the best effort internet access strategy, that was a very key success factor for the internet. So most developed quality of service solutions are not used, especially not end-to-end, and the session-based and any kind of session-based quality of service is extremely unlikely to happen over the internet. So we somehow have to keep it simple, and we believe that incentives are a possible way forward. Incentives are proposed as pieces of information usable to make traffic management decisions. It's intended to be lightweight and not session-based, but it should also enable more detailed SLAs over the internet. And there are examples for that in our paper. So thank you for the assumption. I look forward to your questions.
Are there any clarifying questions? Let's move on to the next speaker. So, Tadal.
Hi, thank you. Am I audible?
Yes.
Okay, awesome. Greetings and welcome to my presentation. My name is Sata Sengupta. I'm a third-year PhD student at Princeton, and today I'm going to make the case for passive, real-time, and fine-grained RTT monitoring inside the network. This is work done with June Kim and my advisor, Jennifer Exford. Next slide, please. There has been a lot of discussion in this workshop already about how RTT is an extremely important QA metric. RTT relates directly to throughput, has an influence on video quality of experience and page load time, and is especially crucial for latency-sensitive applications such as online gaming, algorithmic trading, and so on. But it's not just enough to measure RTT, however. We need to measure RTT while the application is running and a real user is being affected by it. Such in-network RTT monitoring is possible now thanks to the advent of high-speed programmable switches. If an in-network device can measure RTT, it can enable network adaptation strategies such as routing and scheduling in response to significant rises in latency. For example, the programmable switch could select a CDN replica with lower latency. It can reroute traffic in a multi-home network setting to improve video QoE, and even enable latency-aware handoffs among Wi-Fi access points. To give a concrete example, we see to our right a scenario where IP Anycast-based CDN replica selection is happening. A programmable switch in front of these replicas notices significant rise in latency to the current replica, and then reroutes traffic to a different replica that can carry more traffic at the moment. Next slide, please. So in this work, we propose P4 RTT, which is a tool for RTT monitoring and network adaptation written in the P4 language, a language designed for the programmable data plane. This tool would be running in an in-network programmable switch on path between the client and the server. We call the location of this switch our vantage point. The vantage point sees a stream of packets from both directions. It has an RTT measurement engine that computes RTT samples for each flow and sends them across to an analytics and adaptation module that takes actions based on the RTT. It can also send some statistics derived from these RTT samples, such as the minimum RTT in a window, to the control plane for further processing. We perform this RTT computation by matching data packets with ACK packets based on TCP sequence numbers. Now, this can become quite difficult to scale when the volume of traffic is large, which is especially true because certain vagaries of TCP traffic like retransmission and reordering force us to maintain flow state for a large number of flows, while the high-speed data plane is extremely resource constrained. We're able to pull this off by designing a computation method that consumes constant space as opposed to a software tool like, say, TCP trace. Furthermore, our tool doesn't depend on the TCP timestamp option that is sometimes unreliably implemented. Next slide, please. Finally, I'd like to present some preliminary results obtained from our campus dataset. The dataset is anonymized, and this study has been approved by Princeton's IRB and PITR. We had thousands of packets per second going to and from host machines within Princeton to the external internet. We ran TCP dump on our vantage point close to the Princeton's gateway router. This gave us the ability to divide the total client to server RTT into two components, as you can see to your left, the internal leg and the external leg. The internal leg accounts for the fraction of the RTT that is due to the campus infrastructure, while the external leg accounts for RTT beyond Princeton's control. What you see on your plot to the right top is a comparison between wired and wireless RTTs in terms of how much the campus infrastructure contributes to the total RTT. We observed that for the 90th percentile RTT to YouTube, the wireless part of the network adds significantly more latency compared to its wired counterpart. In fact, it is possible to expand our setup to include more vantage points along the path so that we can divide the RTT into even more components to pinpoint exactly which part of the in-campus infrastructure causes this increase in RTT. Now, to the bottom, we evaluate the accuracy of our tool under load. We compare accuracy against the software tool TCP trace, but for fair comparison, we limit TCP trace to order of one space. We implement a prototype in the P4 language and simulate it faithfully in Python for ease of conducting experiments. Early results indicate that P4 RTT is able to collect 98% of the samples collected by TCP trace const, despite several severe resource constraints. The distribution of RTTs is also similar, as you can see in the plot to your right bottom, implying there is no noticeable bias against smaller or higher RTTs. We wish to expand the study by deploying our prototype to our campus testbed, by testing some of the network adaptation strategies that I talked about, and by exploring the possibility of including quick traffic. I invite you all to take a look at our paper for more details, including a link to our campus testbed called P4 Campus. Thank you.
Thank you. Are there any clarifying questions? Okay, let's move on then to the next speaker, Al Morton.
Thank you. Thanks for inviting me, and thanks for listening today. So I stand before you as the person who literally terminated my wife's teaching session on Zoom by trying to finish the potatoes in the microwave oven. We all have things to learn. So I wanted to start out talking about the user's dream pipe. And it's been mentioned a few times here, but always available and sufficient capacity and so forth. But when we want to get that anywhere on Earth and without the qualifiers I listed above, it's a pipe dream. And we all need to work together, obviously, to accomplish that. One thing I did that I haven't seen many do is to consult a survey of users. One that I pulled out here was to try to find out what the users want. 2,500 users late in the UK. They want what they don't have. Everyone wants reliability. They want more capacity in rural areas. They want their ISP to bundle the security and privacy features they don't have. No mention of latency, though, probably because the guys in sweatpants in the basement aren't filling out surveys. Next slide, please. So we have a fundamental hierarchy of the metrics that we've previously standardized: fundamental, derived, single figure of merit. We have the 7 fundamental metrics that we don't want to forget about. There's another hierarchy there of singletons and samples and statistics, and we can use them to create derived metrics. The other derived metrics that we've done beyond delay variation and a packet delay variation and inter-packet delay variation, which compare 2 delays, are reliability and Matt Mathis's model-based metrics, some others, maximum IP layer capacity, which draws together loss, round-trip time, packet delay variation, and others to measure up to the megabits that ISPs advertise. So we need to structure when we standardize the metrics, and this is for everyone thinking ahead. We need to have the definitions and the workload definitions, stream definitions nailed down. But we also want some flexible parameters for those. Nail them down when we're actually doing the measurements. Reporting the results, we want to have the frame of reference that makes the interpretation easy, like the gauge on a tachometer. The RPM metric fits that pretty well. Every engine has a different red line. And figure of merit, these are combines many metrics into a single number and has the strengths of weaknesses, but people like that kind of simplicity. We have the objective interpretation of packet measurements, which is possible via subjective testing, and that's the ground truth. So any metric that has a ground truth is a better one, I think, and I'll try to push that forward. Next slide. So I want to wrap up with a couple of proposals, and the first one is a new derived metric, sort of new and shiny, like the pipes above. It's the number of users supported on ISP access, and effectively, on gigabit access, we can easily see that the number of bits per second is greater than a single user consumes today. Advertisements are picking up on that. There are also benefits for latency and delay variation, but we need to define the standard user streams or the number of apps or app streams that can be supported. And maybe the new metrics over here we're defining looking at in this workshop can help with that. And the standard user streams, the workload, that changes over time, so it has to be registered. We can't argue about it for a year. And finally, the old derived metrics, which users, again, pick up on the connectivity, availability, reliability. COVID-19 made this really clear to a lot of people that reliability is important, as when the house became the hub for everything. We have standards for point-to-point availability, reliability, and so forth, and always derived from loss. Measurement systems can they usually require connectivity to begin their work, but they need to set up, and when the measurement setup fails, that could be the most important info. So you want to derive that from your testing and make it available as well. So there's the old man hanging on a wire. Thank you for your attention.
Are there any clarifying questions?
That's a quick one. Do your metrics or proposals deal at all with the asymmetric nature of so many service lines, i.e., gigabit down, but only 30 up?
I think, sure. When the applications only require a certain workload up and a different workload down, then that would be what we would be trying to emulate in an active measurement. Also, purely loss-based connectivity measurements reflect that as well.
Mary, you have a clarifying question?
Me? Yeah, I have a clarifying question. Al, when you said metrics with ground truth, I was confused a bit whether to interpret the ground truth as a metric that's grounded in some physical phenomenon, or whether ground truth, by ground truth you meant metric that's easy to explain and to relate to. If you can clarify, please.
It's a combination of the first one, Omer, where you're grounded in a physical phenomenon, like the physical bit rate of a link, and you're trying to assure that you're actually getting that when you're asking for it. Also, the ground truth that comes from subjective testing, when folks are trying to say this is a QoE metric, now we have a direct comparison with sort of the coming from the mean opinion score of studies that have been conducted, and so there can be a ground truth for these single figure of merit kinds of metrics. It's much safer to have that kind of ground truth rather than to decide all the coefficients separately and just based on consensus. Thank you.
Thank you, Al. Moving on, and we're at discussion. seems we don't have, Dave. Dave is first in line. Good morning. You're free to speak.
So I have a limited amount of buffer space myself, and I like to talk to other people's slides. Is it possible to bring up the first presenter's slides again, please? Oh, that's definitely not the first presenter's slide. Oh, good. You're talking about all kinds of great stuff in this other slide. I arrived late, so maybe it was the second presenter, the one that did the P4 analysis. So anyway, sorry to occupy more than 60 seconds. If you can find that one for me. The core part, when I looked at that, is that it was of the bottom 90% of the RTTs for a BBR and pacing based system, YouTube, which is great. We've just shown how well YouTube works on the campus network. However, that kind of traffic is usually already, although it's partially capacity seeking, it is capacity limited. And for example, analyzing Dropbox would be a better way of taking a good look at, still not the slide I'm looking for, obviously, but taking a look at
the next one. Please.
Okay, sorry for, there we go. I love CDF plots. So my first question was, again, criticizing constructively, I hope, the use of YouTube for this analysis. However, you can continue to apply this to other sites, knowing that what the structure of their back end actually is, to see how well they're doing from your perspective. And I think that's very valuable. However, I make this comparison to this discovery of the cosmic background radiation. Throwing out the top 10% of the worst case samples is, I've always found that the world is more interesting if you look at the anomalies. And if you could repeat this exact same analysis, but throw out the bottom 90%, you might find some interesting anomalies and statistics that will help make everyone's internet experience better if we can find out what those anomalies really meant. That's all.
Thank you, Dave. Next is Alex.
Yes, I have a question to the first presenter, to Sylvester. And this concerns basically the incentive-based aspect, basically, in your talk. So one thing that I was wondering is basically, is this an incentive or is it really a priority? Or maybe another way to frame it is, who gets to assign the value of the incentive to packets? And basically the threshold there, this looks pretty much like a priority. But would be good perhaps to clarify this, and depending on the answer, I'll have some follow-up questions.
So without using the queue, or?
Yeah, how should, so Sylvester, do you want to respond, or?
Yeah, if I can, without using the queue. So
yeah,
as the end user may be able to assign it, but then it has to be policed by whoever owns the resource. And in a good case, we demonstrated that you can do a way of packet marking when you take into account the priorities of the end user. So you can encode hierarchical resource sharing into this in some cases. But in a short answer, it could be the TCP. In fact, in the basic assumption is that the edge device in the network does it, and it can be a collaboration between these, and it can maintain hierarchy of resource sharing targets.
Okay. Yeah, because so this sounds to me really more like a priority, and I'm wondering actually why you call it incentive-based. I think basically as an incentive-based, it's well one thought in my mind is it's very easy for a user or for an application to always ask, well, I want to get the highest priority, I want to get the best service, I want to get the biggest priority. But an incentive is basically, well, what are you willing to give me in exchange, right? So basically this brings up the question, for instance, for monetization, for instance, but I think basically you say this would come to a policing plane, that would not come directly to that.
So sorry, we should.
It's okay.
Okay.
We'll go back to the
I
queue.
answer in the Slack.
Vidi, you're next.
Hi, I have a question to the second presenter. It's just a very small question about it. The slide said it doesn't rely on timestamps. So how do you measure the round trip time when there is a retransmission? Because for TCP, you don't know what's a data packet, what's a retransmission, right? So without that, how do you do that? That's very intriguing if you do that, and I would just like to learn more.
Would you like to respond quickly?
Yeah, sure. So what we do here is we keep some flow state which indicates so the flow state tells us whenever there is retransmission essentially. So we know the left and the right bounds of what is the valid measurement range for traffic that is going on right now. I'm happy to talk to you offline more about this. There's more details in the paper as well.
Thank you.
Thank you. Gori, you're next.
Hi, I have a question for Al. Al, the pipes over which my data comes have multiple sections. So when I'm troubleshooting, I want to know which section has a blockage or a constraint or an impairment. How far are we along the pathway to finding out where the problems are rather than the overall pipe performance?
Would you like to respond, Al?
Sure. Gori, I think there you're talking about needing segmented measurements and also sort of aggregatable or composable results. And by composable, I mean sort of a spatial composition where you can add up the measurements and get a view of the end-to-end. And that should actually correlate with end-to-end measurements pretty well. So I think probably the solution is the measurements of subpaths, which seem to be more and more possible with the deployment of the flexible infrastructure, VNFs that make measurements and so forth. Am I getting to your question there?
Yeah, because I like the answers you have, and I'm looking for those on a per segment basis, I guess. Yeah, okay, that helps.
Good. I think the dream pipe, when it's 1 gigabit, it's actually revealing the bandwidth limitations elsewhere. Personally, I've experienced that in my home, and when I was signing up for gigabit access, they said, "Well, you won't get this over Wi-Fi."
Thank you. Bob Briscoe?
Hi, thank you. It's actually a follow-on from Al's discussion again, and it's that intriguing idea about number of users as a metric. Clearly very difficult, but I'm going to make it even more difficult because it triggered something in my mind that I've always been slightly angry. Well, I'm slightly angry always anyway, but about the fact that we get a carved out bit of a shared medium sold to each user, and where there's a shared medium, there's usually a lot of the other say like on a cable network, a lot of the other channels are actually unused, and you could be getting more usage or more capacity for one of the users if only they weren't sold this pipe. And that's purely a sales thing. It's not a technical well, it's become a technical limitation, but it started off as a sales thing. And so when you talk about number of users, if the user in any one household could be using other people's capacity, that actually makes that number of users metric sort of even more difficult to be meaningful, because someone who allows you maximum sharing but not guaranteed, how do they answer that question?
Can I take that on?
Yeah.
Randall?
Sure. Go ahead. Sorry. Go for it.
Thanks. I think it could also be phrased as a number of apps available for use or supportable. And again, for that, we need to know the workload streams, the number of those that can be supported on a particular service, would be valuable to know. The mixture of those that a particular household is trying to activate would be useful. I didn't mean that to segment particular users, but
No. I'm not saying
you're absolutely right. Service subscriptions tend to segment the amount of bandwidth a particular household can get, and there are times when some households would like to use more than that, and that might be permissible.
I'm just thinking it'll be useful to make a metric that incentivizes that multiplexing or sharing across the capacity of households rather than perpetuating it.
Okay, worth some thought.
Yeah.
Okay. Back to the queue, Sylvester.
I would like to say a few more things about this incentive. So the method I presented is not intended to be an incentive itself. It intended to help incentives. And for example, the functions you use, how you distribute your values among your flows can be like an incentive. So in that method, packets of the same flow or same subscriber are not marked the same, rather according to distribution, and this function defines the distribution. So and an incentive can be, for example, if you haven't used internet access for a while, you are allowed to transmit with a higher speed for a while. I had a presentation at ICCRG about multi-time scale fairness and things like that. And for example, this kind of multi-time scale fairness can be realized with this. But there can be other incentives like getting higher share for a while for some kind of compensation, like money or using less in the future.
Thank you. Sada?
A quick comment to Dave because he said certain things about the presentation. So thank you so much for the constructive criticism, of course. The idea here was to get a representative sample of all the RTTs so that we are able to figure out what is it that is anomalous in that distribution. So that we wanted that to scale first and then look at the anomalous RTTs. But thank you so much for the other comments as well.
Next is Rich Brown.
Okay, thanks everybody. Is my mic working?
Yeah.
Good. I really appreciate all the good thought that's gone into this workshop. But I see an elephant in the room. There's a lot of good metrics that we could gather, but the equipment that's currently in our homes and out of our control injects random latency into all these measurements. It can be like between 10 and even 2,000 milliseconds. Is it even possible to build reliable and actionable metrics based on those shifting sands? And what can we do to think about making the situation of the CPE at the home better?
Thank you. Next is Roberto.
So the survey had, I guess, the unsurprising result that everybody wants everything. I think one of the things that I would wonder is if we change the survey design a little bit to ask what trade-offs people are willing to make, if that wouldn't give us a little bit more information. For instance, if I was willing to give up half of a gigabit, assuming that, if I want to halve my bandwidth in order to get substantially better latency, with an explanation of what that actually means, is that the trade-off that people would take? I think that is a very powerful way to ask the question. And that's something that I would be very interested in were I an ISP, for instance, because that's something I can monetize, and that drives incentives in the world that we're in today.
Okay. Next is Stuart.
Hey, a couple of quick comments. First, just to echo what Dave Tatt said, excellent point to avoid things like YouTube that are inherently source limited because they don't really stress the network, so they don't find what's wrong with it. But my question was to Al Morton. And we hear this example many times about the potato in the microwave broke the internet. And I wondered if Al did any more analysis. And I'm asking because I hear this all the time, a lot of the time from people at Apple who are not networking experts, sometimes people in leadership positions. And they say, when the microwave turns on, Wi-Fi loses packets. And that's why you should not slow down for packet loss. Your application should speed up. I ask these people, did you take a packet trace? The answer is always no. And when I've taken packet traces, when I put the microwave on, it raises the noise floor. Wi-Fi lowers its channel rate, and that causes a queue to build up. And if the sender doesn't adapt to that change in rate, you get massive queue overflow. So all the packet losses from queue overflow. It's not mysterious voodoo microwaves making the packets disappear. Did you do any analysis, Al, of what the cause was?
The short answer, Stuart, is yes and no. I can tell you this, that the microwave was in direct line of sight with the Wi-Fi beacon that my wife's laptop was using. It was within 10 feet of the microwave, and like I said, I really put the potatoes in there to finish them up before dinner, because my objective was to have dinner on the table as soon as her class was over. And so that kind of reduced my possibilities to do packet traces. But I think that's a good idea. I mean, I can certainly repeat the experiment, and I'd be happy to get back to you on it. Thanks.
So I don't doubt the symptom you described, and I guess my suggestion to everybody in the meeting is, if you have this experience, before you blame it on packet loss, do a packet trace, and you might find it's not loss, it is rate adaptation and queue overflow.
Thank you, Stuart. Now we're back to the queue, and Sylvester.
I would like to comment on this CPA and user equipment thing. That I agree that this is a point to solve. But in many cases, like most of the gamers, they don't use Wi-Fi, and there is a reason for that. And if you solve that problem, gamers might start using Wi-Fi. But still, there are issues in the network. There can be bottlenecks in the access network. There is the international part of the line. There's a reason for most applications using CDNs, and if you want to have like a decent web page, you have to use CDNs. So you could democratize that, because while using CDNs, like there are advantages of using CDNs which cannot be avoided, but part of the reason is that the international line is, for example, is not that good. So look for, I disagree with looking at only at the CPA and the UE. I agree with also looking there.
Thank you. Next is Jana.
Thank you. I will have two comments. The first one is Al's position paper. I really enjoyed reading the draft, Al. Thank you for writing it up. And I think that it's actually, I enjoyed it because I think it's asking, I don't think it proposes anything strong. I'm not sure that you would argue it is, but it asks the right questions, I think, and it consolidates a number of things. And I enjoyed reading about what people asked for. But what becomes evident is that people are asking things based on what is available, what they use right now. And you note this in the draft as well. And we want to push that. We want to make more applications possible that they don't know about yet. And so we are trying to push it towards a direction that they may not yet understand. So that's something, a bit of something to keep in mind. The second comment I'll make is that in general, if I'm out of time, I can actually queue myself back in for my second comment.
Okay, yeah, you're just hitting 60 seconds.
Yep, I'll queue myself back.
Okay. Next is Jim. Oh, you're muted.
I want to note that the microwave phenomena is exactly the same as kids, stop doing what you're doing because my teleconference isn't working, and that what Stuart said is exactly correct. And it doesn't even have to be you. It can be somebody who happens to be sharing that same Wi-Fi channel, who suddenly is using, half or more of the transmit opportunity. So your queues suddenly start to grow when your bandwidth needs are higher than the available bandwidth. So what Stuart said is exactly what's going on. It's rather than something really specific to microwaves. It just caused the available bandwidth to drop, and Wi-Fi adapted to that, and then the queues started to build.
Thank you. Next is Gino.
Yeah, I just had a couple of comments on what Roberto and others had said. Obviously, there's always a trade-off on latency versus bandwidth when you do it outside of hardware acceleration. That exists in the retail market today. You want a gaming router that doesn't do a trade-off, you'll pay $1,000. That's there. You can go buy it. In the CSP space, it's a different story. You can't sell a $1,000 router to a CSP in the home. There's no business case for that. So there is a trade-off. Maybe it's 10, 20% on the low-end socks. Maybe it's 40 to 50% of your bandwidth. But it's there, and consumers are willing to accept that. I see that today around the world with many carriers and many end users. And you're right, gamers do know Ethernet is best, but a lot of them are still using Wi-Fi. In fact, on a lot of consoles, Nintendo and whatnot, there is only Wi-Fi. If you play competitively, you still have to use Wi-Fi. You have no choice around that. And in terms of the potato, I love the potato. That's going to be the quote of this workshop. There are CPs and chipset that can detect very accurately non-802.11 spectrum users, microwave BB monitors. And again, the issue is cost. We've tried selling that. We've tried deploying that. It does exist, but it's really hard to make a business case for a CSP when they invest that kind of stuff. So it's kind of relegated to the retail market.
Thank you. Back to John.
Good, Randall. So my this is a high-level thought, and I'm not going to be able to do a great job of articulating it very precisely in 1 minute, but I'm going to try anyways, and I'm going to flounder a little bit. I hear this thing, and Stuart said this, but I'm not going to put you under the bus here, Stuart, but I'm going to disagree with you just a little bit about saying that something is wrong with the network. I don't think things are wrong with the network. There are things that make the network less useful in particular ways. And I do want to try and shift this notion that I mean, 30 years ago the network was used for certain things and it was fine for those things. Today we use it for other things, and it's good for those things and not so good for some other things. But thinking about that something is as being wrong with the network suggests that you have an idealized view of the network, and maybe that's worthy of chasing. Maybe that's good to chase. However, as we understand, users aren't going to be chasing that necessarily. The reason we like gamers are because we tend to be more aligned there. Users, gamers are trying to really do a good job of trying to go closer and closer to the network engineer's view of the network, because they are trying to minimize latency at the scales that we care to minimize them. And we enjoy that. And that's why we like gamers as an example, a good user for this. But I want to urge us to think about what the current network or a property in the network, say delay or whatever it is, makes difficult and makes for poor quality of end user experience. Because ultimately, I think that is what drives adoption. And I think that's what ultimately we care about. A network is only as useful as its use.
Next is, unless Stuart wants to respond, next is Rich Brown.
Okay, I wanted to respond that Jana was saying the network's not broken. I'm sorry, it is. If I step on the accelerator in my car and it slows way down and then it picks up, I take it to my mechanic and I say, something's wrong with my car. It's not working. If I start to dump a lot of data into the network through my router and the latency goes to pieces, my router is broken. There's no other interpretation of it. And you know, if you want to call it buffer bloat, or you want to call it responsiveness, or you want to call it any of those things, it's no less broken. Thank you.
Thank you, Rich. Excuse me, Jonna?
Randall, and thanks for the response, Rich. I'll note that doesn't mean it's wrong with the network. My son has a car which cannot accelerate beyond 70 miles per hour. That's a feature, not a bug, right? Not everybody needs and should have a race car. So what I'm trying to articulate here is that let's not talk about right or wrong with the network. Let's talk about what it makes possible. That's the more interesting thing. As a network engineer, I think that we all betray our origins as network engineers when we start talking about, hey, that latency just went up, therefore it's bad. But if you're sitting back and watching Netflix, you didn't even notice anything. You don't care as an end user. There is a tension there. I'm not saying that I'm again saying this in a blunt way. I understand the nuance here, but I'm necessarily trying to push us towards towards talking about usefulness rather than right or wrong.
Thank you. Next, Omer.
I have a comment. So Rich, thanks for joining, and thanks for provoking healthy discussion. But I want to use your comment as a trampoline to pivot a little bit, and please don't take it as any kind of argumentation or anything like that. I'm just trying to extend it a bit. So a consumer believes that if they do something and it doesn't work, it's not working. A physicist says that, well, if you dump CO2 into the atmosphere, the climate will change. This is how systems work. Climate is not broken. But consumer is looking at their world. And the question here is not so much of whether consumer thinks that it's broken. Yes, consumer will think it's broken. Question is, how much money will they put onto it? And will they put enough money so that people like China will be able to scale up manufacturing to a way where it will be sustainable to deliver the advanced solutions which are available in the enterprise market to the customers. As a reminder, an hour of work of support engineer of an enterprise company costs probably more, not only how much manufacturer will see profit from the device, more than the entire cost of the device, including packaging, shipping, what's not. So it's not about whether it's broken or not. We can argue about absolutes, and probably we should not argue about that. It's endless. But is there money there? Is there enough money there to shift the market? And if we believe that there is, then how to make an argument that actually consumers should care about it to the degree that would incentivize the entire economy to highlight the economic possibilities of delivering lower latency devices to broader population. So I just wanted to take your comment and to trampoline it slightly sideways, but not too much. Thank you.
Thank you. Jim?
People seem to be making arguments based on, oh, well, we're going to have to pick one. And courtesy of the work that Toki and Dave has done and that Jonathan Fawkes has brought to market, there's a counterexample. You can have your cake and eat it too. If you haven't played with one of Jonathan's routers, you should. If you're an open source guy, go run OpenWrt on several of the Wi-Fi chips that are in the market. So I don't believe it's a good argument to say, oh, we're going to have to, we need to pick because it isn't possible to solve this problem. We have the counterexample.
Thank you, Jim. Rich Brown.
So Jim sort of stole my thunder. I give away a few percent of bandwidth on my OpenWRT router to get nice, stable, low bandwidth. Omer, you're exactly right that there is an economic trade-off, and I am hoping that we can come up with a way to give vendors, service providers, as well as hardware manufacturers, an incentive to put in FQCODL or Cake or Pi or any of these technologies, so that, because I want all their customers to call them and tell them their equipment, I'm going to use the word broken again, their equipment doesn't behave well, and they could fix it, and we have a known solution. That's all. Thanks.
Thank you, Rich. Dave.
I don't want to jump on that one, but I wanted to talk about a use of language that has crept throughout our language in this discussion. It's the word consumer. Because most of us are working from home, we're actually producing things. We are actually contributing to the economy. If we were just consuming, the economy would have collapsed and everyone starved to death. So I've tried to switch to using a different term, netizen, where we are interacting with the world through the internet and still part of the world. And if we thought about enabling netizens to participate in this world, I would hope that we would see more actionable items. I'm not going to touch upon the previous two comments on this plus Q. Thank you.
Thank you, Dave. Rich Brown.
No, that was just a question, or a +1 for Omer.
Oh, okay. Okay, sorry. Jim. I think you're muted again.
I'm sorry, I've lost my train of thought. So.
Oh, okay. Jana.
Oh, I'll go in because the line is empty. Dave, I don't think that it's consumer in the sense that you're sitting back and just eating up a TV show, right? It's a consumer in the sense that you're consuming services that somebody's offering to you. So netizen or not, I am still consuming my ISP services, whether I'm producing content or not. So consumer depends on what layer and what exactly we are talking about as consuming. That's it. I do want to share that. My point was not so much to say that there is I appreciate that latency and buffer bloat and responsiveness are important to us today. I don't think that they are the end all. 10 years from now, hopefully, we won't be talking about this problem, but we'll be talking about other problems. And that's what I want to draw attention to. We are not here to just solve one problem. We are trying to come up with a way of measuring what the or not a way of measuring, but articulating or figuring out how to describe network properties that are useful. This is why I said that I think Al's draft is actually quite useful. It talks about what the user sees as important. And the one thing we did not talk about is just connectivity. One of the biggest problems for users is just having a reliable connection. Forget everything else. They're pissed off, and it happens often enough that they lose connectivity and they don't know who to point to say, hey, my network is broken. This could be because of the device. This could be because of whatever it is that's going on in the ISP's network. It could be a number of reasons. But there are very basic problems for a user that we don't talk about. And in part, like I said, this betrays a bit of a network engineer's view of the world, right? Those are problems that we put under the rug because we don't think about them, because we can't do anything about them. We chase the problems that we want to solve, that we can try and solve, that we believe we can try and solve. Whether we necessarily will solve them or not, I do not know. But there are, from an end user's perspective of the internet.
Yeah, no, we should probably move on a little bit.
Sorry.
That's all I've got. Thank you. So it turned into a bit of a rant.
Next, Bjorn.
Yeah, thanks. I'm beating the same drum that Jana is here. That I feel like the discussion is sort of devolving into how do we fix buffer bloat, or what to do when the network is not providing sufficient capacity or something like that. And if what we are focus, if we want to focus on the metrics, then that should be the focus as well. How do we actually measure whether or not the network is delivering what we need it to do, and then how to fix the problems that we discover is actually another topic. So thanks.
Thank you. And then Jim.
We will be here in 10 years. If we do not successfully expose the problem and enable economics to drive things into the market, the economic cost of solving this problem is actually extremely low. Yes, today Jonathan's router costs a bit more, but that's because it's not widespread and he's actually providing some additional services. But the actual incremental cost can and should be effectively zero. It's almost entirely software in these devices. So again, we have to expose the problem to the world, point some fingers, shame some people, and enable people to vote with their dollars.
Thank you, Jim. And that's the end of this discussion. So now we move on. We're mostly on time. And next we have, sorry, Kilki?
Kilki, yes. Kalevi. So, hi everyone. So my name is Kalevi Kilkka and I have done some work with this quality of service and quality of experience some 30 years. Somebody may even remember me from the IETF meetings in the 90s, but I don't know. Okay, the point here is that I'm actually proposing something similar that Sylvester actually proposed in the first presentation today, that I think that it would be very good idea to somehow change the mindset of quality of service. This is, of course, very ambitious proposal, but and also, okay, I start with the remark that actually I have already presented this in 1997 in some IETF meeting, so it is quite in a way old idea. But then I'm not a salesman, as Vint Cerf said in his keynote speech. Also, engineers should be also some kind of salesman. I have not really been that. So even though I have proposed a very similar idea already some 20 years ago, and then I worked with Nokia and made even some 15 patents and so. But anyway, still the situation is that even this DiffServ was defined at IETF in a way that was based on the fundamental idea that applications have different quality and quantity requirements, and then the task of the network is to satisfy those needs. Okay, this is the mindset, but still every one of us knows that the best of internet and TCP/IP, they do not comply with this idea. So they don't really care about the applications. So in a way, my proposal here is to build something that is somehow more robust than best effort, but still something that is based on the best effort model as such, and just forget all of the application requirements, except in some, maybe in some very specific cases. So what could be more robust? Okay, the second slide, please. Yes, thanks. So I'm now calling it this incentive-based quality of service. So in general, I think that it's a much better idea than relying on the satisfaction of specific quality requirements to build mechanisms that really create incentives for the application and users to behave in a way that is beneficial for all during the congestion. Of course, that means there's adaptation to the situation. Now, of course, TCP/IP in a way is responsible for that, but that is of course it's also somewhat not so robust model because it's up to the application users to implement those TCP/IP mechanisms. So, and then in this idea or model or mindset, the users and the application are totally free to use the network and the mechanisms as they wish. So that is the optimal case. So nowadays, of course, to some extent we can rely on, that's the reality that we can rely on the TCP/IP to take care of the congestion situation and network adaptation, and of course also video applications that are adaptive are very, very reasonable. But okay, then the technical solution, or one technical solution that actually was patented by Nokia some 20 years ago. I think that all of the key patents are already expired, so you are free to use this, everyone. There should be no any problem. But there is some like 15 patents. There are 2 key patents, and then all kind of. I try to solve all kinds of problems that has already actually discussed during this workshop. Of course, they are not necessarily perfect solutions, but there are some solutions. So the solution is really based on just the 2 kind of priorities: delay classes, kind of delay priorities, maybe 2, maybe 3. And those would be freely selectable, but low delay comes with a kind of penalty. That means that you get actually, in this proposed system, you get less bandwidth if you select low delay class. So that is the only kind of penalty. And then we need something like at least 4, maybe preferably maybe even 8 priority levels to implement an incentive to adapt to the situation in a way that when you are using lower bit rate, you get higher priority, which means lower packet loss ratio. And I cannot go into the details, but this works very nicely with TCP also, so TCP/IP. So it's, but the main point is that there need to be some incentive, and that is the principle is similar to what Sylvester proposed also, that the decision to reject packets should be based on the innovative to the value of the packet. And this is also this kind of system based on the priorities or priority levels also somehow realize that principle. So those packets that are highest value, they are transmitted if there's not enough resources.
Sorry,
to.
you
Yes,
need to
I'm
start wrapping up.
just
Okay.
ending. Yes. Okay. The point here is that what I'm asking here is that is there any interest to really promote this kind of incentive-based quality of service mechanisms? Yes. That is the end.
Thank you. Are there any clarifying questions? Okay, let's move on. Next we have, I'm not sure who's speaking, Neil?
No, it's me. It's Peter Thompson.
Okay, Peter Thompson.
Hi. Okay. So this is the joint work between ourselves, Vodafone, and Domos. So we've heard a lot about the importance of things like responsiveness, and we've also talked about things like propagation delay and so forth. And we actually come at this from the perspective of how does an application see a network, and the issue with responsiveness, for example, is sometimes the issue is latency, but sometimes the issue is packet loss, which can really have a big impact. So next slide, please. So our perspective is that loss and delay really need to be considered together. So we think in terms of what we call quality attenuation, which we write with delta Q, is really the combination of both. So it's a combined measure of the extent to which the network is not instantaneous and not faultless. And this is basically what applications see. We've had some discussions earlier. Dave Tatt made the point that actually a lot of the interesting things happen in the tail of the distribution, and we would completely agree with that. So actually, when we're thinking of quality attenuation, we're looking at a distribution and not an average. So we could say our good news is we think there is a measure from which many of the things we've talked about previously, like RPM and so forth, and 99th centile and so on, can be derived. The bad news is it's not a number. But the reason you need a whole distribution is different applications on their protocols are sensitive to different aspects of this. So any single moment or centile that you pick will not be universally applicable. The other advantage of looking at things this way is you can specify a bound on how bad this attenuation can be. In the picture on the right, it's the blue curve, and if you measure it, we'll talk about measuring in just a second, and you can see that the probability of getting it, everything arriving sooner than you needed them to, then you know you're doing better than you needed to, and you have a test for what constitutes good enough. Okay, can we have the next slide, please?
One interjection. Somebody has an open microphone. Please, I would like to ask everyone but the speaker to mute. Thank you.
Okay, so the way we measure this is to basically get one-way delay timings from one point to another, but using different packet sizes. And actually, when you look at it, just looking at those raw measurements frequently reveals a lot of interesting behavior. But what we can also do, if you take data like that and you sort it by size, you can actually decompose this into some useful components. So if for each size bucket, you will get some packets that have the minimum delay for that size, and you do a regression through them. You can extrapolate that to what would be the delay of a hypothetically zero-size packet, and we call that component G. It's a kind of geographic delay. It's basically like the propagation delay that was spoken about on the first day. And then the extent to which bigger packets take longer than that is something we call S, the serialization delay. That's obviously a function from packet size to an additional delay. Quite often that's roughly linear. And when we subtract those two factors, what we're left with is what we call the variable delay. The serialization delay and the geographic delay are essentially statically determined. They're functions of the layout and the technology of the network. They change relatively slowly. You notice when we measure this kind of thing, we notice shifts in G, for example, tell us about route changes in the network, stuff like that. Changes in S might tell us that a route now has a different number of hops than what it had previously. So you can pick up a lot of phenomena from this data. But the contention effects are basically in the pushed into the variable component, where we could look at the distribution and the tail, and that tells us a lot about what's happening with queuing at some bottleneck point. Okay, next slide, please. Okay, so this I forget who said it now, but somebody was arguing that what we needed is a composable measure, and this is one. This quality attenuation is a thing a bit like noise. It's something which adds up as you go along the digital delivery chain in either direction. It accumulates, and what you get end to end is the appropriate sum of what you get in the individual segments, and that's also true of the individual components. So this provides a method for being able to, as Al Morton was asking for, being able to localize where issues occur. You can see if the end-to-end quality attenuation is bad, you can see where that came from. And by decomposing it into these different parts, you can also see what that was. You get a lot of insight into what that was due to. So this is a measure that you can process to extract a lot of the single value metrics that we've talked about already, but which actually contains a lot more information. and we've used this in a number of contexts that always reveal interesting things that you didn't know. And certainly, for example, shows clear differences between the performance of different kinds of access technologies, and can give a lot of information about Wi-Fi. For example, Domos have used this, looking into the behavior of Wi-Fi systems. Okay, that was basically what I had to say. I hope there are some clarifying questions to pick up the things that I meant to say and forgot. And otherwise, I look forward to the discussion. Thank you.
Thank you, Peter. Are there any clarifying questions? Wes.
Yeah, really quickly. So I like the approach. Do you try and take into account the fact that routing switches and anycast and things like that can cause issues with your measurements over time?
Basically, we're relying. Okay, so we're relying. But okay, generally speaking, we do these measurements by injecting a low rate stream of test packets with appropriate randomness, so that they appropriately sample what we want. We are relying on the test packets following the same path as whatever we're interested in. So yes, there could be phenomena which impact that, but what the measurement will show you is that there's something, you're missing something, right? You'll see weird behavior, and then you can start drilling down to where is that happening and what's it due to. So yes, there are a number of things which could impact this, but it will provide a baseline for drilling down into what they are.
Okay. Thank you. Moving on to, I'm not sure who's speaking. Is it Mingri?
Yeah, Mingri. Here.
Okay.
Am I okay?
Yes.
Yeah. Okay, thank you. Hello, I'm Mingri, a first-year master student from University of Nebraska-Lincoln, and this is the collaboration work from Vidi at Apple and Li Song at the University of Nebraska-Lincoln. I'm going to talk about our work, user perceived latency to measure congestion control algorithms. Next slide, please. Okay, thank you. CCAs is an important component of transport protocols, such as the TCP. It's usually measured and evaluated using metrics such as the throughput, RTT fairness, and while these metrics are important for network operators, they are not sufficient to describe the latency experienced by the users. Most CCAs use RTT to evaluate delay performance. The RTT of TCP is usually defined as the time from the departure of TCP data to arrival of TCP ACK. RTT measures the delay inside the network. However, what user perceived time is from the user's application's request to the arrival of application response. On this delay time is what we proposed as user perceived latency, UPL. The UPL measures the delay inside the network and not the hosts. The additional time could be the time that TCP data at client or server sending buffer. They are not counted as RTT time, but would decrease the performance for users. Okay, next slide, please. In our experiment, we test all Linux TCP variant in the latest Linux kernel, but we only show three of them for the clarity of the figure. The figure shows the UPL and RTT of Cubic, BBR, and the CDG. We build a bottleneck link with 10 megabits per second speed with 100 milliseconds of RTT delay time. We use a single TCP connection to measure RTT and the UPL collect data at both client and server sides. Also, we generate 1 megabits per second UDP cross traffic in both directions of bottleneck link. Each time the client will send 1 byte of request and server would respond with 1 megabyte data. The CDG and the BBR are in our experiment are delayed-based CCAs, and they successful in keeping low RTT even the buffer size increases. And the cubic is a loss-based CCA, so it has a longer RTT as the buffer size increases. However, we can see that the longer RTT does not, the longer UPL does not necessarily indicate a longer UPL. For example, with 400% of BTP buffer size, the RTT of cubic greater than the RTT of BBR, but they have similar UPL. Also, with 400 BTP buffer, cubic's RTT greater than CDG's RTT, but UPLs of cubic lower than CDG's. So that is that RTT is not a good indication of latency perceived by the users. Therefore, where RTT is important metric to measure the packet latency inside the network, we want to propose an additional metric UPL to measure the latency perceived by the users. By proposing the UPL as one of the performance metric for CCAs, we hope that it would promote better design of CCA to measure what actual users' experience would be like. Thanks.
Thank you. Are there any clarifying questions? No? Okay. Let's move on to discussion. I guess so. So let's start the queue, and looks like Omer is, oh, he has a clarifying question. And he's in the queue, so I don't know which you want to start with first.
It's the same one.
Okay.
I have a clarifying question to Mingray. I hope I'm pronouncing the name correctly. My understanding is that UPL is somewhat equivalent to the what's so-called responsiveness, but it is basically inverse of responsiveness. And to that degree, what mechanisms have you used to measure the user part of the perceived latency? Was it HTTP client server? Was it some kind of binary transfer? And to that degree, well, another question that I have, feel free to ignore it if not enough time, is have you seen effects of using rack TLP on the UPL? Thank you.
Okay, thank you. How we measure the UPL? So in our experiment, we measure the UPL in the application. We not measure at the TCP layer. So we know what is the request, what is the response. And
but which application is that?
We write a new application. This very small client and server with only socket system call.
So it's basically a transfer of a buffer.
Buffer? You mean how we?
Anyway, let's take it offline. Sorry about that. And did you have a chance to experiment with TCP rack TLP in addition to the congestion controls? I'm just curious.
Yes, the environment we use is Mininet, so we have delay time, the delay, the parameters, and also the buffer size, and we also can change the request size and and response size, but it does not. It's always indicate that the UPL is different from RTT.
Thank you very much.
Thank you.
Thank you. So first in the queue, I think, is Dave, and I think I have your slides.
Yes, thank you very much for letting me point to that. I wrote out what I'm going to say so I can fit it in the 60 seconds. So everyone here knows I'm a proponent of fair flow queuing, and I think that that alone can solve a huge percentage of the problems we've observed in a multi-user home. That once you have enough bandwidth, you need better bandwidth. And when it comes to this incentive-based QoS concept and the development of the smart queue management and ultimately the Sched cake thing, and analysis of hundreds of third-party QoS systems and bandwidth management systems, we ended up settling on a very simple structure. We settled on 3 tiers of access, or 4 mirroring Wi-Fi. They were priority, meaning voice and video conferencing, best effort, and background. And we assigned, because we're doing good queue management, we assigned them a fixed maximum of bandwidth relative to other stuff. And that seems to be working pretty well. We're seeing things like tunneled voice cellular traffic using those markings and getting 0 loss and nearly 0 delay and so on. And we've made those statistics visible to the users. And I think that one of the most important things is making good statistics of some sort visible to the users. But that said, after looking at all those other QoS systems, how users perceive how they want to manage their bandwidth, the smarter ones, is vastly different from what we designed. And getting to where we can express our stuff, any level of stuff we're trying to describe to them, in a way that people will now understand is really, really important. That's it. I'm going to paste a link to those statistics in the chat.
Slack. Next is Ahmed. Can't hear you. You're muted. Sorry. Still muted. Maybe we should move on to Alex until Ahmed gets set.
Yes,
Alex?
yes. Hello. Yeah, I wanted to comment actually on the first speaker. So and I think actually one thing so I like this incentive-based and so forth concept here, and I think actually really to me this seems to be also about fairness, and I think this is actually something to perhaps look more into how we can let users specify basically their trade-offs. Basically, it's one thing to say, well, I want to be prioritized, I want to hog the resources and so forth over others, but it's another to be able to support mechanisms that allow you to specify which one is more important for me, right? The trade-off basically, is it more important the latency? Is it more important the loss, the capacity and so forth? What is it? So basically, these types of mechanisms I think are very interesting to look at. One question perhaps, or perhaps one thought is also how users could indicate this. Basically, if we want this to happen dynamically and so forth, basically does this require potentially also ways of signaling where you would put these types of trade-offs, because allowing to do this basically makes things inherently fair.
Thank you.
Can I have a short answer?
Sure.
Yes. So yeah, I agree absolutely, and we really did consider this issue also some 20 years ago and have some solution, but in the proposal that I and we made Nokia was that in principle the user is and the application is free to mark the packet as they wish, and then in a way somehow declare that what are the priorities. But then we need also some measurement at the network boundary to measure that how much they are using these priorities and how much data they are putting on different levels of priorities. And then need to be some kind of feedback loop from the used resources and priorities. But this is, of course, complex issue.
Thank you. Stuart.
Sorry, I was looking for the unmute button. A quick echo to what Dave Tatt said. It's very common to ignore anomalies and outliers. But actually looking at the outliers is actually most interesting because that's what makes the video call fail. I had a question about the graph, and I don't know the slide number, unfortunately. It was the one that showed the base speed of light latency S, the geographic latency. And that graph seemed to show that the geographic delay is dominant. The serial, no, go back. That's the right graph.
Sorry.
You had it.
Okay.
Yeah, that one.
Okay.
The G is dominant. Serialization delay becomes dominant for large things, and the variable bit is negligible. And I'm wondering how you measured that, because that's how we'd like the network to work if there were no buffer bloat. But in reality, in all the measurements we take, V is 10 or 100 times bigger than S and G.
Should I respond to that or Q?
We can respond.
Okay, so this graph is just kind of illustrative, and you know, Stuart's absolutely right. The thing that the constant investment in higher rate serialization technologies has done has basically been to pretty much eliminate the serialization delay. So yeah, if to plot this for a real modern technology, the green line would be almost flat, and the variable part would be bigger, but that's very then dependent on the specifics of the technology. Things like cable and Wi-Fi with shared media are very different from things like DSL, where you have dedicated media, and the geographic delay though is still significant. That doesn't go away as the bit rates have gone up. The speed of light hasn't improved. So yeah, I would agree. G and V are the mostly dominant factors now.
Thank you. Can't figure this out. Ahmed, are you in queue again?
Yes, I am.
Okay.
Just with regards to the hello, can you hear me?
Yep.
Okay. With regards to the user perceived latency to measure CCA, congestion control algorithms, I don't understand why an application needs to know about congestion algorithms and measuring it. The other thing is, from a user perceived latency, it's about the application and really the server delay in the server and being able to serve the client or the request has to come into play to give a reflective user experience on that particular application. So I think WS shouldn't be about the window size of the response of the application server. It must also include the server's ability to access a database, search, blah, 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 blah.
Okay, thank you. Sorry, Sylvester, I totally missed your spot in the queue. I apologize.
No problem. Is it me next? Sorry.
Yeah.
My response. Oh, okay. So for that, the user perceive.
Oh.
I'm sorry.
Sorry, I was I was going to go to Sylvester next, but you can go after, or go ahead, Migiri, and we'll go to Sylvester. Sorry. Oh, okay. Sorry, Sylvester.
Okay, so okay, thank you, and no problem at all. And I would like to thank Kalevi for taking his work to us. And I would like to emphasize a line from his paper, because I think that line is a really good inspiration on how to solve some of these problems. And that is to change the code of the system from quality requirements satisfied or not satisfied to good incentive, bad incentive. And about a given incentive, either my incentive or his incentive, I think that a way to compete on incentives and translate these traffic management strategies is maybe more interesting than to say that, okay, this incentive is good or this incentive is better. So, and somehow, if that competition happens, then allow the users to have an opinion about like which incentive he would like to use for which service, but don't bother them by default. So somehow have meaningful defaults, but allow users to change them. And what is really important about this is to get experience about use and misuse of incentives, and how it can be realized by, or how it helps traffic management.
Thank you. Next is Gavin.
Hi, just a couple of quick comments on the quality attenuation technique. First of all, I don't think Peter mentioned it's been standardized now by the Broadband Forum, and as a result, a number of vendors are now building that into products. So there are commercial products available that use that. But also, when you look at what we covered in the presentation there, you think about using this in a live network to measure the performance of networks, which is what we're talking about today. But it also has very useful use cases in measuring the performance of equipment in a lab setup. And in actuality, one of the very first use cases of the technique was back in the CERN particle accelerator lab, to select between different vendors and different models of Ethernet switches in that high-speed lab and compare and contrast their performance. And I think increasingly with modern networks, as we're building them out of software and virtualized network functions, we've seen a huge variation in the implementation performance of those virtual network functions, particularly under load and different conditions. And that's where we've quality attenuation in a lab environment is particularly useful. We've used it for low latency DOCSIS and virtual BNGs and a bunch of other scenarios in the lab. So just wanted to mention it's not just about live network deployment. You can use this in the design and architecture and supply chain evaluation phase as well.
Okay. Brandon.
Yeah, in terms of TCP RTT not being representative of QoE or transport RTT in general, that's not particularly surprising given that transport RTT measurements don't incorporate the impact of retransmissions. So you're looking at more at delivery rate, you're getting more of an estimate of throughput, not goodput. In terms of buffer bloat, I see this is something that continues to come up in this meeting. I think it's interesting. I'm curious if folks have an idea, or if there are data sets where people have looked at 4-access links in residential networks. How often is the propagation, or is the RTT that a user would observe significantly greater than the minimum RTT, meaning that there's some sort of standing queue at the user's access link? Because given the way, given modern web traffic's workloads, I'd be surprised if it's constantly building up queues, and it's kind of comes up to, is buffer bloat a significant problem for a lot of different types of traffic?
Thank you. Omer? I think you're muted.
Can you hear me now?
Yep.
Awesome. I had a question to Mr. Thompson regarding the geographical delay, variable delay, and serialization delay. Back to that slide that Stuart had commented on earlier. The question is, in your experience, is the geographic delay truly constant for a given pair of peers? The reason I'm asking is that in my experience, most recently working in traffic in Facebook, the routes change quite frequently, at least a couple of times a day, when the ISPs are running out of budget for their transit agreements and they're switching to the next least expensive agreement. Because of that, the well, coordinates do not change. The network topology does change. This was my experience. I wonder whether your experience showed different different results, and I would be interested in hearing a bit more about that. Thank you.
Shall I take that or Q?
Go ahead and respond.
Okay. Yeah, you're absolutely right. I mean, when we call it geographic delay, that's just a kind of shorthand. Yeah, we totally see the effect of route changes and even in so when we early on we did some exploration of VDSL access lines. And if you do a cluster plot of the G and the S, you can observe the effect of the modem seeking different operating conditions. And yeah, there's the G is not boring. There's a lot of information in that part. Exactly the kind of thing you were saying.
Thank you. Just wanted to see whether there was something super exciting and surprising there.
Thank you. Stuart.
Thank you. I put myself back in the queue because I wanted to answer a question that Ahmed raised. He said, why do applications need to care about congestion control? So remember, congestion control is rate adaptation. It's how the sender knows the right rate to send to not overflow the network capacity. If you're using TCP or QUIC, then that's done for you. But if you're building your own thing on top of UDP, then that's your responsibility. I talk about this in my submission on the workshop agenda page. It's the first one. I remember talking to some people doing a video conferencing client, and they claimed they regularly saw 40% packet loss, 50, 60, sometimes 70% packet loss, and they claim this is just normal on the internet. The internet just loses 60% of the packets. And clearly, if you do a TCP trace, TCP dump of a TCP connection, you don't see 60% packet loss. So they were getting lost because they were sending 3 times faster than the network could carry. And that was what they were causing the packet loss. The internet was not losing their packets, they were causing the packet loss. And in a shared queue, that hurts all the flows sharing the queue. And that's why any application built on UDP, you have a responsibility to understand congestion control, because you hurt everything because the internet is a shared network, which is actually the title of my submission. Thank you.
Thank you, Stuart. Jana.
Thanks, Randall. A couple of quick questions. One is on the CCA talk. I like the measurement of this application delay, and I think it's really actually useful. It indicates something about queuing that happens. However, it is not necessarily a purely congestion control metric. It's beyond that, and that's important to bear in mind, because actually it captures some. This gets trickier when you get to QUIC, because the TCP has a sequential delivery model. QUIC does not. So it's trickier to measure something like this and compare TCP versus QUIC when you start doing this. Separately, somebody asked the question of how often is Brandon asked the question of how often is RTT greater than the network's min RTT. Effectively, that's how I translated the question in my head, anyways. It's actually very often quite high, Brandon. If you look at packet traces at servers, you'll see that it can grow up to 10, 50 times the minimum RTT within a connection's lifespan. Now, that doesn't answer the follow-up question that you asked about how frequently does this actually cause problems to other applications, because that's fundamentally hard to measure. But it does grow. How much does it affect other applications? I don't know.
Thank you. Vidi.
Just, Jana actually answered the question that Brandon asked, and I was going to yeah, just address that as well. And I want to mention, yes, it is very huge as compared to minimum RTT. And for example, if I do a test between my home and my workplace versus I do a test by remote logging in and just doing the test at the workplace, there is like huge difference. Like I would say, yeah, 50 times probably sounds about right. And that means there is some lot of buffer bloat. It's irrespective of whether I am the one who's sending the other competing traffic. The buffer bloat is just there in the network. I mean, it's probably because somebody else sharing the same cable is also sending the traffic, but it's the variable latencies and the variable RTT as compared to the min RTT is pretty bad. Yep.
Okay, thank you. Next is Jim.
This problem is usually what other people do to you, and that's why buffer bloat went relatively unnoticed. Us humans tend to do one thing at a time and do one measurement at a time, and it's literally when you're doing both things at a time, whether it's you or somebody else on your network, when you see the problem. If most applications, by themselves do just fine by themselves. And so this is really back to the internet, or your home network is a shared network. And it's shared in ways which are more subtle than most people realize, whether it's the microwave raising the noise floor on Wi-Fi, or your neighbor with his own Wi-Fi network, right? So this is exactly what Stuart said.
Thank you, Christoph.
Oh yeah, I wanted to comment also on the buffer bloat question that Brandon raised. I think one of the problems is that when it happens, it is extremely short-lived. And let's say if now on my network I start a huge file transfer, you will all see a 1-second blip in my audio, and then WebEx is going to adapt to it, right? And so you will see it, and then you will forget about it. But it happened, and so that's one of the reasons I believe why buffer bloat is so problem today, is because it's so hard to root cause it and to point the finger on it, because it's so extremely short-lived.
Thank you, Christoph. Brandon?
I think I did a poor job stating my on the statement earlier. I agree that RTT throughout a connection may change. Sometimes that's going to be due to the congestion control behavior of the sender. If I'm sending faster than the bottleneck link, I'm going to build up a queue there. And yes, we see that in production as well. The RTT observed throughout a connection will be higher than the minimum RTT. What I'm trying to understand is how often are these significant increases in buffering? Like we've talked about latency under load. Folks have been talking about we might need to extend the time that these load tests run to really fill up and saturate the buffer. Is that necessary? Is that type of situation realistic? Because for me, okay, I have a 1 gigabit per second up-down link at home on a fiber connection. Unless the total rate of packets arriving at this link is 1 gigabits per second, we're not going to have a queue build up there on either the uplink or the downlink. And so how often, if you want to saturate that link and tell me here's how big the buffer is, how often will that scenario actually occur?
Brandon. Rich Brown.
I'd like to speak directly to Brandon's question, and I'm delighted that you can get a gigabit. Up until about 6 months ago, I had 7 megabits DSL, and my neighbors here all did too. And the answer is queuing delays, buffer bloat, if you want to use that word, gangs up on everybody a whole lot. Gangs up all the time. And so, I'm resisting the urge to ask people to start a ping test and then run a speed test during this webinar. But I think that's instructive. If your ping time changes very much, your router is treating your data pretty badly. That's my thought.
Thank you, Rich. Dave.
I'm sorry, Brandon. I'm not sure if I can even ask this question. My hope would be if you could ask around inside Netflix and ask how many are using IQ routers at home and why. You might understand a little more deeply the problems that are faced at the bottom parts of the market. My own comment, though, was that once we deeply understand these issues, the content providers, the ones that are making the most money, I really do wish that they could join us all in providing a better in-home access, things like better research, Comcast Innovation Fund, something like that to help make the network as a whole better for everyone. That's it.
Thanks, Dave. So I think Brandon went from popping in and out. Jana.
Two quick comments. One, it's again, people. I'll note that these 60 seconds make it hard for me to be nuanced, which is probably the right thing to do here, right? I don't want to spend 5 minutes talking about something here, but I'm going to say something and walk away. Two things. One, Christoph, you said that the buffer bloat that happens, that's witnessed, is short-lived and it goes away. You're exactly right. That's what I've seen as well. And you also said that it makes it difficult, therefore, to point a finger at it and say that's the problem. That begs the question, though, if you can't point a finger at it, is it really a problem? So that is my sort of my bomb drop. I'm going to speak to Rich as well, who said that this is a router behaving badly when it holds onto a packet. That's the equivalent of somebody screaming at the computer saying you're not working well. It's working as it's supposed to do. This is what I keep saying. We have to stop talking about this as bad behavior, as wrong behavior. It is doing what it's supposed to do, and it's serving a purpose. It's not, if you want to change the behavior, let's figure out how to do that. But it is doing something, and it's doing that thing well.
Thank you. Bob Briscoe.
Yeah, I wanted to pick up on the perception that people might get that Brandon's saying he's got a gig, a symmetric gig, and therefore his data can't chase his queues, and they're never going to catch up with him. That sort of gives the impression that this problem's going to be solved when we've all got more bandwidth, but the middle of the market has more bandwidth when it's filling it with more data. And so it's only because Brandon's ahead of the market that he's not seeing the problem. Once everyone's got 1 gig, everyone will be filling 1 gig as well. Just like everyone's filling whatever they've got now when they're in the middle. It's only the people at the bleeding edge that don't see this problem. And quickly to pick up on Jana's point, or his bomb, the interruption is just more. Yes, it maybe is how the internet works now, and it doesn't have to be how the internet works, though. It's unnecessary, and we can make it better. That's what we do. That's what engineering task force means.
Okay. Torles.
And so this ongoing discussion about the buffer bloat and sometimes the RTT increasing because of it. Yeah, we all want to get rid of it in the network, but I think what we should also remember is that there are higher level things in the, above the transport stack, in the media stack that can be done. I'm not sure how many of you have experienced that. You had sometimes this buffer bloat increase, but your video application, I think specifically Zoom is subject to that, is continuing to have a long RTT. So over the time of a conference, your interactive response will get worse and worse, and you have to restart the application to basically get back to your normal low latency or low RTT. And those are really, problems where there are a lot of solutions in good codec stacks to catch up and do other things like, doing different streams and so on. And maybe that's something that we could start to collect information about and document, at least informationally, in the IETF because video conferencing applications on average really very often suck in that respect.
Thank you. Brandon.
I think the symmetric gig point here, I think even if you have 50 megabits per second or 25 megabits per second, somebody brought up pinging during this call. That's exactly the type of data set I'm looking for, right? If I take users with different access types and I look at how often throughout the day is their contention at their access link for the uplink or the downlink, what am I going to see? Because the point I think John will make and a couple other folks make is this is short-lived and goes away. So what does that actually mean in terms of the impact on the user? Again, people were talking yesterday or 2 days ago about you need to extend the time of these tests to 20 seconds or 30 seconds to fill up this entire buffer for some of the tests that were being done of a saturated link, how much queuing is induced. If the problem is typically short-lived and goes away, do we really want to execute that type of test, or is it not representative? And the other question I have here is, I think when there is this type of buffer bloat, I think it's typically that the uplink buffer is saturated or the uplink is saturated, not the downlink. I realize the uplinks are typically going to be more constrained, but again, how often is the uplink under contention? Thanks.
Thank you. Jim.
I have a number of problems with all of this. People are saying, oh, the edge of the network is the ISP last mile. It's not. It's usually a Wi-Fi link inside the house or a mesh network inside the house or in fact, your cellular network. The other problem is the amount of buffering in a lot of these devices is not just measured in milliseconds, it's often measured in seconds. On an airplane, I've measured 740 seconds of buffering. I have measured 8 seconds of buffering on my bed in my house. The point of the long test is to push the network to where it stops working and find out how much, or if it malfunctions. Okay, that takes time. That there are transient events a lot of the time is also extremely true, but each of those can destroy the quality of experience for many applications.
Sorry, Jim. We got to move on. Thank you. Christoph.
Yeah, I wanted to respond to Jana's reply to me on if the problem is hard to catch, is it actually a problem? I think the problem is hard to root cause it and pinpoint it to that the reason for the short glitch in WebEx is buffer bloat, and so that's why I believe we need to build the right tools and measurements to actually be able to point the fingers on the root causes so that then they can actually get fixed.
Stuart.
I'm going to echo partly what Christoph says, but maybe more strongly. And I'm going to paraphrase unfairly what Jana said. So forgive me for that, Jana. But in effect, what Jana said is if the end user can't diagnose the problem, then it's not a problem. And I don't think that's the right way to think of it. If your car a couple of times a week has the engine just die halfway through a busy intersection, that's bad. It doesn't happen all the time, but a couple of times a week. You take it to the mechanic and he turns the key and the engine starts and says, looks fine to me, what's your problem? The fact that the problem is intermittent doesn't make it less of a problem.
Thank you, Stuart. Rich Brown.
Yeah, I wanted to respond to Jana sort of on the same theme. If somebody said to me that my routers, well, you asserted maybe the routers are working as designed, and I'm going to say if it's part of the design spec to queue milliseconds or hundreds of milliseconds of data, it ought to be written on the box. And I don't think that we design our boxes that way. So I'd like to, I think buffer bloat's real. I'd like people to think about it seriously. I've been running an RRUL test here, and my latency has gone from maybe 16 milliseconds to a high of maybe 50 milliseconds. So I just put my money where my mouth is here. Thank you, Jonathan, for a good router.
Thank you, Rich. And Jana for the closing of the discussion.
Randall. Very quick responses. I'll start off with Rich, your point. I don't know that putting a router, a delay metric on a box is going to make it much of a difference for the common user. To you and me, yes, but not to the normal user. Stuart's point, yes, Stuart, right? I mean, you know that I'm being provocative here a little bit, but there's a hint of truth in there, right? I'm a network engineer like all of you. I would like to see buffer bloat be addressed. However, I still am looking to understand, to your point of if my car breaks down twice a week at an intersection, that's very quantifiable. So that's not it's not a good analogy, I don't think. And if I told my mechanic that, they would certainly want to go fix that, because breaking down twice a week in the middle of an intersection is a pretty big problem. However, if once in a while my car makes a squeaky noise somewhere, and it doesn't really bother anything or anybody, my mechanic is likely to say, well, keep going until something actually breaks. So to me, that's a better analogy, because if I can't put my finger on it, then it's kind of hard to fix it. So I think there's a lot more to be said about incentivizing and about what we should be incentivizing. And I don't want us to rat hole on buffer bloat either, because I think the quality of a network has a lot more to be discussed here, as we've seen in the past. And I do want to see in the future, towards the end of the day, if we can move towards talking about things like security, like privacy, like all kinds of other issues, like connectivity, like I said, basic connectivity, which we haven't even talked about yet. So my thoughts.
Thank you. And I guess that takes us to the end of the discussion. I'll hand it back to Wes. I think are we at break? And
Omer actually should be the one you're going to hand it back to.
oh, Omer, sorry.
Yeah, well, I
My bad.
could not really escape the duties.
We are indeed at break.
We are indeed at break. We will get back in 10 minutes, and we will start the third session for the day. The moderator will be Geoff Houston.
I got a question for the ending of this thing. I really had a great breakout session yesterday. I'm not really sure though. What are we really aiming for in outputs? Arguably, we just went through buffer bloat hell, and there are other issues involving metrics. Is there some way we can get to a simple, clear, actionable, overall executive style statement at the tippity top of whatever we do next?
So we'll talk about that at the in the last hour, and I have some slides to drive sort of that discussion. In fact, so I'm hoping Omer will turn it over to me, and we'll see what we can do. It'll take some work on the mailing list after this is over as well. But
yeah,
I've been trying to think about how to document those discussions that went on afterwards, right? That, you know, I think you guys had a lot of good discussions. So.
Yeah, well, I'd like to try to stay focused on the outputs in that last hour so we can nail this piece of Jello to the wall. And that would be great. Thanks. And I'm gonna go grab my lunch real quick.
Is there ever an end to these things? You said at the end of this thing.
Yeah, there is. At some point, the diameter of at some point, sun will expand and it will not be relevant anymore.
We have
workshop. I do. Yeah, maybe
That's the internet quality Hotel California.
That's what it is.
John, to your question, I believe that the truth is that it's very easy to get used to the better level of everything. And once we get used to it, we always look for something even better. And as of now, it seems that the culprit is that, okay, many places we have quite a bit of bandwidth, but is it sufficiently good bandwidth?
I think that's what we've discussed.
Yeah.
I don't think so this is one of my standing issues here, right? Is that I think we are rat holing on a couple of issues. And those are the issues that we want to hammer on. But I'm not convinced that those are the only important issues.
Agree.
We are now at the end of a break time. Hi, my name is Jeff Houston. I'm moderating this next session. So we'll press on with the agenda using similar format. And first up is Christoph Pasch with responsiveness under working conditions. Over to you.
Thanks. Am I the only one who sees the slides very tiny?
Same here.
Okay.
Jeff, could you full screen?
I can.
You might need to go to single monitor on a Mac. There you go.
Perfect.
Yes. That works.
So, hello everyone. So, this is a presentation about a draft we submitted to IPPN a few weeks back. It's about measuring responsiveness under working conditions. So I'm not going to go into all the technical details that we present in the draft, but rather tell the big story around it. So why did we start off with this? Well, the first problem was that, well, we have known about buffer bloat for more than 10 years now. It exists since far longer than that. Solutions exist also since then, CODL, PI, and so on. But still the problem is very widespread. When you go out and measure it, you still can measure latency under load. And so why is that so? Well, we believe that one of the problems is that we need to raise awareness to the problem and create tools that allow to actually measure it and quantify it. This awareness will create the end user, enable the end user to be the forcing function and create the market incentives to actually, for the vendors to actually fix the problems, right? And by having the tools available to actually measure it, the vendors can actually, I say vendors, it could be operators, whoever, operating system providers, right? All of these, they can actually use the tools to actually measure the buffer bloat and see if their solution actually fixes the problem, right? Another problem that we also realized while we started working on this is, well, what is actually buffer bloat? There are many different ways that buffer bloat can happen. It can happen in the routers. It can also happen in the server, in the web server application, right? Also, how do you measure it? Should you use an ICMP ping, a UDP ping, a TCP request response, or should you use HTTP3? How do you actually create the working conditions, right? The load on the network. It's surprisingly difficult to actually do that. And there are a few tools that are already trying to measure buffer load. We have these reports, fast.com, there's the waveform website, there's some command line tools like Flint, and so on. But all of them are measuring it in a slightly different way. And if you run them one after the other, you will get a very huge variance in the different numbers that you can measure. So that's why we thought, hey, it's actually time to standardize a methodology to measure responsiveness under working conditions. Next slide. So what do we measure here? Well, first of all, we focus on responsiveness for the end user. And what does that mean is it implies a few things. It implies first we use modern protocols. We don't use ICMP ping. Nobody transmits data on ping. We don't use UDP ping neither. We use HTTP2, HTTP3 would be an option, TLS, right? And we are very well aware, like what Matt presented on Tuesday, that buffer bloat can happen at different layers, and you can measure at each layer, and each measurement is valid. We just need to be aware of the layer that we are measuring has a certain meaning. And so measuring at HTTP2 has meaning for us because we want responsiveness for the end user. And also because we want to measure it for the end user, we want to measure everything, all stages of the connections, like DNS handshake, TCP handshake, TLS handshake, HTTP request response, and HTTP request response on the load-bearing connections. And finally, we want it to be user-friendly, meaning we want to finish the test within 20 seconds. And we want it to output a single number. We don't want it to output a CDF graph because the normal end user won't be able to interpret these things. So our methodology, and that is described very much in detail in the draft, is we create stable working conditions, which is pretty difficult actually to reliably create these conditions. Because the problem is you don't want a short-term spike of latency created. You want it to be stable because you want to run multiple repetitions of latency measurements, right? And so we create multiple HTTP2 bulk data transfers that are ramping up gradually, and we are adding more and more connections to it so that we can reliably fill the pipe. Then we measure responsiveness, and we measure it in two different ways. First, we measure it with HTTP2 GET requests on the load-bearing connections. So the load-bearing connections are creating one HTTP GET for a huge file, and then we run small GET requests of just 1 byte to measure that are multiplexed on the same connection to measure the latency. This allows to expose buffer bloat in the network and also on the server implementations. And then we measure also separate on short-lived parallel HTTP2 GET requests. That allows to measure while the DNS, TCP handshake, and so on, there might be prioritization happening in the network. So TCP handshake might be faster than the GET request and things like that. So we measure all these different stages of the connections. Next slide. And so then we crunch the numbers and output it as round trips per minute. The reason is why do we express it as round trips per minute? Well, first of all, we want a single number, and we want it to be the higher is better. We don't want people to look for a lower number. Finally, expressing it as round trips per minute allows for a very nice range from the low tens to the upper a few thousand. So it's all very simple to express it. For example, over a phone, you can say, hey, I have an RPM of 600. What is your RPM, right? And finally, it allows for a nice analogy to car engines, revolutions per minute, right? So we have standardized the entire methodology. We have published it in the IETF draft. We have a tool that is available in the macOS beta. It's called Network Quality. You can run it and you can see the output here, the output's capacity, the number of flows that ended up being used, and the responsiveness. We also have the same kind of tool on iOS as a UI. And if you jump through the hoops to enable this UI, you can see the responsiveness UI in developer settings. As I mentioned, it has been standardized, and we are also encouraging people to set up servers. And so in the draft is a specification of how you can basically host this kind of service so that you could run this tool against your own server.
Okay, time's running out now.
Perfect. I'm at the end. So that's it.
Great.
Thanks.
Clarifying questions, please. I see none. So thank you very much. Let's move on to Bob. Are you doing this presentation?
I am. Sorry, I was using the wrong mouse.
Yeah. Over to you.
As long as you move it. Yep. Okay, so this was aimed at the question in the call for papers for a simple metric that will focus people's minds, users, service providers, whatever. Next slide, please. Jeff. Right, so this is just to give a bit of context. What we want to do is have a metric for varying packet delay, and one that we can all agree on gets people focused. And this is how variation occurs in different scenarios, a couple arbitrarily picked. On the right, you see an orange one, on the left, a blue one, and in the middle, you see them both on the same plot. So you can see the orange one's hugging the x-axis, the blue one's hugging the y-axis. So you can't really see them both at the same time, hence splitting them out. And there's various metrics here you could use, and we want to try and have one that could act as a figure of merit. So it's a question of whether you use the mean. The median I haven't shown. It's quite close to the mean on the right hand one, but it's about less than half on the left hand one, as you can see in the numbers above. Standard deviation, or perhaps 99th percentile or a high percentile, or perhaps the max. Actually, this looks like old slides, because the max is meant to be labeled. It's where the color ends. There's about 4.5 on the left and about 57 or 8 on the right. Okay, next. Jeff, can I have the next? Thanks. So in picking which one, first want to make the negative point that mean or median are distractions. You've got skewed distributions here. The of all the main applications, when you're dealing with measuring at the packet level, the packets are pieces of the objects your application needs. And if you measure the average of all those things, that isn't really representative of what the application can do, because it needs to collect up the stragglers before it can do anything with the pieces, and particularly with real time. You know, if you for instance use the median to characterize delay, and you set your playout buffer at that level, you would be discarding 50% of the packets if you play them out after the median delay. So it's just not, it's just pointless talking about the median. Similarly for TCP short flows, the receive buffer has to wait until they're in order before it delivers them. So any of the stragglers it has to wait for. And even if you've not got an in order delivery, if you've got a datagram type system, you tend to have application logic that has dependencies. So a generalization, which isn't always true, but often, that we're really talking about the user experience being about delivery of an assembled product, or at least an assembling product, you know, in some sort of window, not the pieces. And so measuring at the packet level, mean or median is really doesn't cut it. And because these are so asymmetric, what we propose is, or as a straw man, if you like, that if we try and go for a single metric, it ought to be a high percentile to enable comparisons if we're going to go for one. So next slide asks the question, Jeff, which high percentile? And this is obviously where things get difficult. There's a the main thing is not too high, otherwise it becomes too slow to calculate. Which say someone's having to do tests and they have to do a whole matrix of tests. If each test requires something like, you know, a billion packets in order to get a decently accurate 99.999th percentile or whatever, then it's just going to be impractical. So it has to be as low as is representative, but it still has to be representative of typical application requirements. So as a straw man, 99th percentile, that means an application would be able to conceal it if it played out after 99% of the packets had arrived. Generally, you know, if it set its playout buffer on the basis it might have to discard 1% of the packets, is that reasonable? Does that make it easy to write applications to do that? Because we want to make it representative, otherwise you're not really providing a metric that doesn't have sort of benchmark effects and poor incentives. So just wanted to, before I go on to the last question about how we set consensus on this and things like that, just wanted to make some clarifications. So jumping to the small print, we're not saying you don't also have to specify other things to make this metric useful. We're not saying you don't have to say whether it's one-way delay or or two-way. You don't have to, you know, you have to say whether it's layer 4 or layer 7 you're measuring at, like the previous presentations. You know, you have to give the traffic load, as in Christoph's last presentation, the duration and all the rest of it. But we just want to focus on this one question, you know, and try and get an answer that we can all focus down on. Which percentile should it be? And as long as we have one common one, it doesn't have to be the only one people report, but it's one that people can compare if everyone's got a lowest common denominator. So, you know, which IETF working group? I suggest the IPPM. I think the IETF's a good body to set this standard. And you know, it's also really good, and I'm now going to be extremely sarcastic. It's all the IETF's really good at setting standards, as Spencer Dawkins said, when there's only one choice, and we've got lots of choice here.
Okay, time's running out now, Bob.
That's
any
it.
closing comments?
That's it.
Great. Clarifying questions. Bjorn, that's a clarifying question.
No, I was lining up for the queue later.
No problem. Okay. Gone. Christoph again. Let's go on to the last one in this set, which is an end user approach to an internet score.
Actually, that would be me, Kristen.
Oh, sorry. I
No
was just
problem.
taking the order from the authors. But Kristen, over to you.
Great, thank you very much. So I'd like to talk to you today about a case for an end user internet score. So this is not something that necessarily those of us who understand networks really well would consume, but someone who's not versed in the art, as they say. And it's not all about throughput. We've had several people discuss this already, that clicking at speed test or something like that doesn't give you the whole picture. There's many other things to consider, you know, responsiveness, jitter, and protocol conformance. This is a particularly important thing, and many other factors that we kind of want to roll up into something that evaluates how our internet connection is doing. And also a key piece of this is that we have different focuses. So some people are really into gaming, we have video streaming, we have interactive video, a number of other things. So the idea here is that we would like to define an internet score that works with different use cases and is a measure of both the network quality and utility. Both of those things are ineffable qualities, but or characteristics, but something that we'd really like to be able to quantify in some way. Next slide, please. So there's plenty of network properties that we can evaluate. We know the kind of standard ones, good put. Latency we divide into two pieces, at least, the idle net latency and the working latency. And Christoph kind of alluded to this. When we load the network, what can we expect to get in the way of latency? And one thing I really like, one way of characterizing this is the ability to multitask, because the network actually handle multiple functions at one time. And then there's protocol conformance. We have existing protocols like ECN, V6, Wi-Fi stuff, and there are new protocols that, of course, we can't foresee. You know, QUIC has come and become an interesting protocol to work with, and someday it may be replaced by something else, who knows? And from this, we want to kind of cook this all together and produce some kind of quality and utility metric that's an abstract quantity. So the idea is to have a dimensionless number that's relatively small, something you can express in just a few digits. Again, higher is better, as we've spoken about with the RPM score. So a higher number means you have a better connection, with no particular upper bound on this, to allow us to expand into the future as things get better and better. The real sticking point here is correlation to user experience. I think a number of people have brought this up throughout the workshop. How can we get this to correlate well with user experience? I don't know the exact answer to this right now, but I believe that something is better than nothing, as long as it's not misleading. So perhaps we can come up with something that will get it to correlate well. And this is a key piece right here. So we want to be able to mediate these calculations with a weighting table. And it's a weighting table composed not of just simple weights, but of functions. And the idea here is that we can try to make this relevant into the future. As protocols come and go, as performance imperatives come and go, by changing this weighting table, because things will change over time. We know this, of course, and to be able to substitute in this weighting table, we can change both how we see the moment in time that we're at and what particular focus we have for different applications. Next slide, please. So our proposal is this synthetic score that we can scale into the future, and the idea is to use both linear and nonlinear transformations. We note that in psychology, a lot of the ways that human perception sort of transfers from a technical metric into a perceptual metric is nonlinear, you know, often mediated by things like logistic functions. We want to be able to express that in here as a piece of this sort of generic block you see here for how scores are put together in other scores that I've worked on. So the idea is to transform these input parameters and then combine them in some ways. And the combination is a pretty important thing. You know, how that combines is more of an art than a science, and trying to get it to work in a way that humans can perceive it as useful. So we pass it through these transformation functions, and then we apply the weighting table to be able to combine these in some useful way as we go forward. And that gives us the internet score that will be, you know, just a quantity. And we can scale this to anything we want to make it into a number you can tell someone in a chat window or something like that. So the idea is it would be some kind of an integer of some kind. So that's all I had.
Okay, thank you very much. Over to discussion now, and Bjorn leapt in first. Over to you.
Thanks, Jeff. Yeah, so just a quick comment to Bob. I completely agree that mean and median are distractions. We completely agree on that. And then I'd just like to point out that choosing a single percentile comes with a trade-off, because one of the things that you lose if you choose a specific percentile is this property that you can measure from A to B and then from B to C and add them up. You can do that with means, and you can do that with other moments, but you can't do it with percentiles. And then the other thing you lose is the generality in mapping that to application requirements, because some applications may be sensitive to a different percentile or a different combination of percentiles than the one that we potentially agree on. So yeah, arguing for the keeping as general a distribution as is sort of computationally feasible.
Thank you.
Come back on that, Jeff.
Yeah, sure, very quickly.
Yeah, it's just an attempt to get a single number, and yes, you know, it would be great. Like I showed, you know, the log scale CCDF there would be ideal, but it's really a single number that people may not even understand what a percentile is, but they know what a number is. You know, and it may be inverted like the RPM metric, but it's a single number. And you know, saying yes, it's not additive, that's true, but I think it's more important that it's representative. And I think a lot of the problems we're having is because median and mean latencies are being thrown about by everyone as if there's some sort of measure of what we've got, and then people say, well, that's not very much, but actually that's not what the application's experiencing, and you know, and what users are experiencing, because we're not talking about the tail.
Thanks, Bob. Phoebe.
Thank you for all the presentations. I have a question to Kristen. Thank you, Kristen, for the internet score presentation. Can we just go back to the one previous slide, the one that shows, yes. So this is great that you have that we have a final score for the user to look at, but is there a way to decompose it back to P0, P1, P2 for the developers to do the debugging?
That's a great question, Vivian. What we found is to make these things actionable, that you know, the scores are kind of like a dimensional collapse. So we're crunching a highly dimensional space down into a single dimension, and we have to be able to reinflate that score. And sometimes it's a direct reinflation by going back to all of the parameters, and sometimes intermediate representations turn out to be very useful. So the idea would be that there would be a diagnostic way of getting back and reinflating those dimensions.
Sounds good.
Thank you. Al.
Thank you, Jeff, and thanks for all three talks. A quick response to Bjorn's comment. You actually can combine percentiles, and we had a real smart mathematician from Nortel contribute considerably on that work in ITUT standards, and it's replicated in an RFC. So we can get together at some point and share the specs that you want to look at. But you know, and of course it has limits as well. And then since Kristen's slide is up here, I think you said that it's more of an art than a science, Kristen, when choosing the weights and the transformations. But my experience is that it needs to be more of a science in order to be compelling in the standards world. And one body can get together and decide on the weights. Another body will say, well, that's all wrong. So you really have to have the justification and the comparison to ground, some kind of ground truth, I think, to make this practical. Thank you.
Thanks, Al. Wes.
Thanks, Jeff. So in the United States, we actually have a air quality index, which is actually defined by the U.S. government. And it's actually an interesting thing that does exactly sort of what you're doing for an audience that doesn't necessarily understand the complexities of each individual measurement. So it actually does a linear aggregation of multiple different measurements with different multipliers, even depending on the range of the measurements, to come up with some random number that dictates to people, can you go outside and exercise? And then they even bin that down into color ranges. So we have, green is good and it's 50 or less, and then 50 to 100 is better. As a scientist, I hate that number. I want to see the individual measurements. I care that the smallest particle is getting into my lungs and I need a really good mask, versus just knowing that it's, bad air quality with big particles, which aren't quite as dangerous and things like that. But for the average user, I kind of like that notion of an aggregated number for people that really can't understand the individual problematic points.
Thanks, Wes. I now need to go and re-find my screen. Everyone's still seeing the same screen, or is it flipped elsewhere?
You have a white screen now, but the next person is Dave, if you want me to take over for half a second.
No, I'm back in business. Dave wants it flipped back again. So back to the first one, Dave, and over to you.
So over the years, we have struggled to find tools and metrics that can universally describe the biggest problem I've been working on, which is buffer bloat. And I only recently came to understand that one of the reasons why the two sides were talking past each other was that on the one side, we had proprietary benchmarks with their own metrics. And on the other side, the work that my project was doing was covered under the GPL version 3, which for all intents and purposes in the corporate America was verboten. People were scared to run the tools or even do the data. So we have relicensed our IRTT tool to be GPL version 2. And all future work of the buffer bloat project will be under open source licenses that are acceptable to all. And moving forward, as we try to find common metrics. So there is a need for this particular draft for open source something, and I'm hoping that we get to work on that one and on any other stuff that we have in the hope that we can stop talking past each other.
Thanks, Dave. Who's next in the queue? Anna.
Yes, I wanted to comment on the combined metric. So the Swedish internet community did some work 3-4 years ago to try and define what was required from internet access, also defining a number of metrics that you would need to support. And we had a lot of discussions if all these metrics would, if they should be weighed into a single metric. What we ended up with was to say that, to pass in a sense, to be a good access for basic access or for a particular use case, you need to meet all these requirements. So the final outcome there was more of a pass-fail. But as a user, you should have an idea that if my access has this security, this performance, various metrics, then it works for this type of application. So it was another way of combining metrics that you could also perhaps have thresholds and say you need to meet these if you should be a good connection for gaming or a good connection for something else. And you could also have, of course, grades for it, but to avoid having to weigh the different metrics together, which can be a difficult task, I think.
Thank you. Kalevi.
Okay, so my question is related to this last presentation and this synthetic score. So what is your opinion about this nature of this score? So it is, I can see two choices, at least two choices. So it can be a kind of satisfaction scale, something like mean opinion score or whatsoever. Or another possibility is to have a kind of utility scale, for example, value of time, which is used in the transportation area to measure the value of different kind of situations. So, and these are different because the value of time or other utility scale is in a way, let's say, more linear or more additive. So what is your opinion about this nature of the scale?
There's a few seconds left in the minute. Do you want to answer right away?
Let me just say that I'm kind of open to both right now, although I tend to lean in the utility direction.
Okay, so that is also my preference.
Thank you. Turles.
So in the IPTV world, where there is no congestion, but the bandwidth is upfront provisioned or reserved, whatever, the key, metric of interest for the quality is the number of disturbances that the user sees on the screen, right? So, I mean, video bloating or something. And if I translate this into the congestion world, I'd say that I very much like the 99 percentile from Geoff, but I think it would be good trying to capture, a metric for exactly when or how often the 99% doesn't happen, but when you exceed it. So in the, IPTV world, broadband access network were said should have at most one such, visible interruption within 4 hours. And, I myself would also like to know how often my internet connection, exceeds the 99 percentile, because it's a big difference whether it's one big interruption or 10 smaller ones. 10 smaller ones would typically be perceived to be much more annoying than one big one.
Thank you. Sam.
Sorry, I was on mute. Yes, quick question clarifying question to Christoph, actually. From a quick reading of your draft, it looks like the mean is used to aggregate multiple working latency measurements. I realize it's a bit more subtle than that because there's multiple different tests for DNS handshake, TCP handshake, and so on. But given the challenges of keeping the link saturated during the latency underload test, why not use something like a maximum? I assume that must have been considered. I wonder why it was discounted.
Absolutely. So a few challenges. So first, we try to detect when we saturated the link, right? So only at that point we start the latency measurements. So we don't do continuous measurements over time. A second point, why not the maximum? The problem with the maximum is it's very highly likely, because we measure at the HTTP2 layer, the maximum is going to be basically a measurement of packet loss. And so the latency is going to be much higher for those particular probes. And so it's kind of skewed. So we were in this difficult, I agree, mean is definitely not ideal, and we would love to have a better understanding of what is a better way to express it. But that's what we currently have. Finding a percentile is also difficult, because another problem that we have is if your network is hugely buffer bloated, measuring buffer bloat takes a lot of time. And then we run against the usefulness goal that we have of finishing the test within 20 seconds, right? And in some networks, actually, our test times out because there's too much buffer bloat in the network. So we are balancing different goals that are sometimes conflicting. That's what we currently came up with. And we would be happy, actually, if people contribute to the draft and provide and suggest other solutions.
Thank you. Next on the queue is Jonathan.
All right, Christoph's going to get a lot of airtime. So first question here is there an open source version of the server side of the RPM test?
It's coming. It's coming. Randall, who shared the previous session, is going to post in the coming days or weeks the server-side configurations. It's very simple. It's all just HTTP2. You need to provide a JSON at the beginning to bootstrap the process, and from there on, it's all just hosting a few HTTP2 files and then allowing an HTTP2 post.
Okay, and any way to direct the iOS client to a different server than the default?
Yes.
Thank you.
There's an option. Yeah.
And Christoph, next one up is you.
Sorry, right. No, I wanted to just highlight one key point on the internet score. Kristen mentioned the weighting table, and the weighting table is really the tool that will allow us to create a score for gaming, create a score for video conferencing, create a score for people who only do email and web browsing, for example, right? And earlier in this workshop, we talked about the nutrition labels, right? And we were wondering, well, what should be the rows? Should the rows be good put, or should it be responsiveness? Well, maybe the row could be, well, your gamer score is 49, your video conferencing score is 600, so it's much better. And so we believe that the weighting table is going to can be the tool that allows to address all the use cases.
Thank you. Next in the queue is Alex.
I was actually, Christoph just stole my thunder. Of course, because I wanted to also comment on the synthetic score. I don't think actually a single score is useful at all. I think all it says is, okay, I can quantify to say, okay, this sucks, or this doesn't suck quite as much. I don't really feel how that helps in a general way. However, I think one can definitely make the case for benchmarking for these different types of use cases, because different things are important for different users. And we were talking also earlier about when this whole incentive discussion about, okay, is latency more important? Is it loss, and so forth? And this basically also helps it perhaps relate to where you would put those trade-offs. What scores better for which area? So I do think. So I think benchmarking is good. The one score itself is not so useful. On the other aspect, also on reinflating the dimensions, perhaps separate comment. I'm not sure I fully actually understand this, because if you say this mapping should be reversible, then this is just an encoding. I don't see how this can be one compact score if you want this to be that way. So I'm a little bit skeptical on that. And anyway, so I would,
think about it and re-cue yourself, Alex, and
all right.
We'll move on to Bjorn.
Yeah, I just briefly want to describe how we do this measuring, or this mapping between application requirements and measurements in the Delta Q system. And that is, for instance, if you have this IPTV, where what you care about is the whether or not there are artifacts for the end user, you can map that to an upper bound on the distribution of latencies and packet loss that is measured across that link. And then you can say something like, you can count the number of seconds that the network delivered a latency and packet loss distribution that was above that bound. So basically the network is too slow now. So yeah, I think that it points, what Turles points out is you need a metric that can also have a well-defined mapping to application requirements, and Delta Q supplies that. Thanks.
Thank you. Dave.
I am looking forward to, again, more open source efforts to make these kind of tools run on routers and on backends for everybody. And I keep pointing out how wonderful Matt Mathis's work, we haven't heard from him today, I don't think, was in making the Web 100 stuff actually very common in Linux. And it is extremely easy to be able to instrument TCP now on the server side or the client side using the TCP_info structure. And I hope that out of that work, out of exploring the kind of numbers we get out of that, we'll actually start finding even more useful metrics for application service providers to use.
Thanks, Dave. Wes.
So regardless of whether we have a single score or a food label type set, I'll argue that we need to enable studying the scores over time, as trends and deltas are likely more important than just a static point in time.
Okay, that was quick. Biddy.
I'm just thinking out loud about the internet score, and if it's, you know, like every application or use case gets its own score, or for example, video conferencing gets 50 and gaming gets 100, and let's say 100 is good, 50 is bad. Are we also planning on, you know, documenting what is the user supposed to do? Is he supposed to play games more, or is he supposed to figure out why his whatever video conferencing score is low, and vice versa? So just thinking out loud, if that's gonna be, you know, the authors are thinking about this as well, or if they have any thoughts.
Thank you. Alex, back in the queue. Yep.
I think I have a difficult on the percentiles and those metrics. I think that I think one thing that is important is to refine these over time and add this time component. Is a little bit echoing what Wes said, but I think also one thing to think about is basically should there be metrics for recent high water marks or recent percentiles, so that we can distinguish basically the long running, basically what we're experiencing of our service versus also again shorter periods and in the more immediate past of time.
Thank you. I put myself in the queue, so I'll put the timer on me. I think in searching for one metric, we're actually engaging in telephone thinking. You know, if the network only had one use, it was really easy to figure out the quality dimensions of that particular use framework. When we set up a packet-based network, we had no use in mind. And we've actually had, you know, a complete panoply of the way applications actually drive the network. And while we might say everyone uses TCP, therefore the network's optimized for TCP, I think that's wrong, and it's kind of tunnel thinking. One metric doesn't solve all of the various applications we use and would like to use. And trying to narrow this down to a single metric of quality, I think is actually kind of thinking about this the wrong way. We actually need to be more sensitive to the various requirements of applications. And that was my minute. Over to Sharat. Thank you. you need to unmute yourself? Sharat?
Hello, is it audible now? Sorry about that. Okay, so I just want to add some points, some thoughts to what you were saying, Geoff, and also with these comments earlier, that I do agree that we probably need to look at the metrics from an application perspective, because that's something I believe a user would understand. And if you listen to our talk yesterday at Canopus Networks, we are trying to do something of that sort, where conferencing application has certain metrics, right? That can be exposed back to the user, that a network right now can support certain amounts of latencies or jitters. And of course, agreeing to Wes that it's a time varying metric. It's not a fixed thing. It could be a particular value today, but it could change tomorrow as well. But making the application the center of exposing these metrics, I think would be useful for both the customers to understand and the developers to work on it to improve it further. Thank you.
Thank you. Wes?
So I don't really know how to rectify the fact that we need different things for different people, and how to, come about with the debugging information. In the DNS world, we've debated adding extra fields for debugging and who actually should be able to interpret, what a software author writes in there, and whether it should be shown to the user or not, and whether they should be given a button that says ignore the certificate error, right? I can say that there are a large number of cases where we have red and green lights, because that's what a user needs to know. Is it down right now.com is one, and is it raining.com is another one, right? They just want to know yes or no. And unfortunately, that's what users want a lot of the time. Does my network work? Yes or no.
Thanks, Wes. Michael?
Yeah, I I believe we're overcomplicating this. I think that there are not so many applications that want latency. There are some applications that don't care, and that's all right. And then there are applications that care much about having little jitter, but when you have little latency, you also have little jitter. Altogether, just keeping latency low and focusing on that as a metric, as something we can measure, is probably going to help very many applications. And then you can try and classify that in applications that care more or less about this, and say this matters for gaming, because even the low rate traffic is going to have low latency here. But then if you have high rate traffic, it may produce latency. We just want to avoid it. I think the bottom line is we aim at low latency, and that's pretty much it. Under load. I mean, that's my 2 cents.
Thanks. Sylvester?
About metrics and video conferencing, it's some applications do have this, but I have never seen an application which said that, okay, it's your line which is the problem, or it's the other party's line which is the problem. Should I solve it, or should the other party solve it? So this kind of finger pointing we mentioned several times these days, that's I think is really important.
Thank you. Rich?
So, yes, thank you. I want to pick up on what Michael just said, that for people that are espousing, we need multiple measures for different applications. I guess I'd ask people to design them and implement them. Point us to the code, we'll run them, and we'll see if we can get any good data out of them. That's it.
Thank you. Wes, we seem to have exhausted the queue. We're a couple of minutes early, but guided by you. Do you want to move on to the next part?
It does seem to me like it's a good time to wrap up if we're in an empty queue and we're 3 minutes before. I don't know. We wouldn't take advantage of the fact that everybody's done.
One of my friends who ran an ISP always said that there were a bunch of gamers that he called low ping bastards, and they were his nemesis. That whenever the network clagged up, the low ping bastards would hit the phones and give him a hard time. And maybe that's what we're talking about. So what's next? Wes, is this the last slide? Yes, over to you.
All right. So I think we've been thinking about what to do in this last hour and trying to figure out how to wrap stuff up. So let me go ahead and steal sharing. And we will go with this. So what's next, right? How do we, this has been a fantastic 3 days of discussion. In some ways, it feels like we came to some conclusions. And in other ways, it feels like we're just getting started, right? And I think that that's probably the right thing to think about. So a little bit of administrivia first. First, yes, the website is still out of date. We apologize for that. We are working on getting it fixed. There's multiple issues, including running a workshop and trying to, get other stuff fixed at the same time. Yes, people have asked, can we publish the slides? Yes, we will publish all 3 slide decks as well on the website. And yes, beyond today, please do consider continuing this conversation in both Slack and email and stuff. So here's what we proposed for the last hour.
Sorry to interrupt, Wes, but nobody can see the slides.
What? Can you see them now?
No.
We can all see the slides, it's just the white slide.
I mean, yeah, sure. We're not seeing what you're trying to show.
Weird, that has worked before. Let me do it this way. Can you see that?
Yes.
Okay. So it won't go full screen and I'll just work through it. That was the administrative slide, but I read it, so you probably don't need to read it. But this is what we proposed for the last hour. One, to try and document some of the conclusions that we agree on. And I'll do that in 2 parts and we'll continue that in a minute. And then for another 20 minutes after that, we'll sort of talk about what the next steps are. What do we need to do that we can do immediately? What can we do in the IETF? What is like longer term research? And then of course, coordinating on the mailing list and continuing to do stuff is a good thing. And then once we decide, okay, here's the next steps, who wants to commit and actually helping? But first off, for the first 30 minutes, what can we agree on? So I'm going to propose the following experiment, and this is where there's a fine line between bravery and stupidity, and I'm going to figure out which side I'm going to fall on for this. So queue up if you have a statement that you want to propose. This is not for discussion. I want you to pick, some statement that you think we agree on. So not, everybody has to agree, but something that you think that the general audience, believes is true. Don't pick something that you think you're in the minority for, in other words. Example is there is no single metric. I think there's been a lot of people that have said that. And we'll write them down and we'll send them all out later, and I will be stupid again and actually start writing some of these down live. After we sort of run out of items, I don't think there should be too many, I'll start a second queue for people that disagree with some of the statements to really push back against it. And this is just sort of an experiment for what conclusions do we think that we actually can come to that we can document in, the final workshop report, and which ones do we still need to think about more. So with that, Jeff, I'm going to ask you to continue running the queue if you can, and I
was just going to volunteer to do so.
Thank you, sir.
Okay, so first up in the queue is Bob. Can't hear you, Bob.
All right, I've actually got 2, but they're very similar. I'm going to say we do not have incontrovertible evidence that latency is more important or becoming more important than bandwidth that would convince Wi-Fi developers.
And your second?
We do not have incontrovertible evidence that buffer bloat is a problem.
Thank you. Jari.
Second, you were missing out the part of that would persuade Wi-Fi developers on the first one.
Yeah. Actually, can I add a word to the second one? We do not have incontrovertible evidence that buffer bloat is a prevalent problem.
Prevalent problem. Jari.
Yes, so the background for this is that the internet keeps changing, and when I make some observations during this conference and otherwise, I still see things that are measurement related, but refer to technologies that may be on their way out, or at least not as useful as before. So I would propose that we say that new measurement or QoS techniques should not rely on reading TCP headers.
Thank you. Michael.
Yeah, as I just typed, I mean, I think we probably have large agreement on this statement from Bob that that the mean and median are distractions when it comes to latency. But for the specific formulation, if he wants to say something, then it's me paraphrasing him. So
that's fine.
Tuolas?
It is frustrating to work on measuring bad network services without simultaneously being able to work on improving those network services.
Where's time to type? Okay. Neil.
Sorry, I don't think hard is the right word, right? Or insufficient or so, right? Yeah. I said frustrating, but there may be a better word, but hard is not good. Thanks.
Thank you. Neil. Can't hear you, Neil.
My microphone's not working.
Neil's microphone is not working. I think what he
Okay,
meant
so
to
in the
say
chat
is,
window, Wes.
yeah, the measure needs to support localization.
Thanks, Bjorn.
Yeah, so yeah. It gets to the point where detecting a problem is not very useful unless you can also find out where the problem is and potentially what to do about it.
I put myself in the queue, and if I wanted one statement, I would say RPM is a useful consumer-oriented metric. The next in the queue is Dave.
In many cases, internet users today do not need more bandwidth, but better bandwidth. I said it, I did preface that by saying in many cases, but you know.
Thank you. Lars.
In general, I'm trying to paraphrase down to the general, but do feel free to disagree with my truncated wording. I'm looking for short statements, people.
Lars.
All right, stakeholder incentives aren't aligned for easy wins in this space.
Chris, I apologize. Can you repeat the end of that?
Stakeholder
incentives aren't aligned for easy wins in this space.
Anna.
And we need a combination of active and passive measurement.
Ahmed.
A really meaningful metric for the user or consumers is whether the application will work or not work. I've put in Slack the percentages and what they mean through a lot of consumer research that the regulators have done. It's like highly likelihood of service availability, likely to get service, intermittent service availability, likely to get service. And then I think from my experience, those have been very, very interesting to people that they getting the service through a lot, and the percentage is reflective of people's perception. Those could be the percentages are kind of like what's fixed. The meaning could change on the application basis. But you can even have them to smiley faces and not just smiley faces.
So Ahmed, your audio is horribly broken, unfortunately. I got the beginning, which I wrote down. If you think you want something else, can you type it into the chat? I'm going to break the rule and go ahead and put that in the WebEx chat as a verbal comment you couldn't quite complete.
I'll be in the chat, yes.
Thank you. Next in the queue, Tuolas.
So I'm wondering if we already are in the phase of beating up these statements, because I'm starting to read the others and think about them. And so for the first two ones, maybe my more positive view on that would be we need better evidence and metric for the fact that latency may be equal or more important than bandwidth, and that buffer bloat is a significant problem to persuade developers.
I'd be fine if you change the top one to that, make it
I think
more
it's
visible.
both of them, right? So I think we need that better evidence and metrics for both of these, right? So for the significance of latency and the
Okay, so
yeah.
I'm going to say for now I'm only adding new stuff because I'm not going to go back and try and live edit old. But that's a good point. Why don't we
in terms of to make it more towards an action item for us, right? Evidence and metrics.
Yeah, that's here, right?
Yep, exactly. That's so actionable, right? So that's
moving on. Roberto.
Why don't we close the queue for new stuff? I think this is a good list, and we'll go on to disagreements here in a minute.
Useful metric for goodness must actually incent goodness.
Goodness. Bob.
We need measurement to be continuous, which is, I think, Michael Beltzer's presentation. We're not colluding in that he also helped my point.
Okay, Dave.
Sorry.
I can't hear you, Dave. You might be on mute.
Unmute, sorry. So while we're doing overarching statements, a lower latency internet, comma, however achieved, would benefit all of humanity.
Kenjiro.
Okay. We need a simple tool to fill a gap between ping and speed test.
Thank you. Between ping
and speed test.
Gavin.
Bandwidth is necessary, but not sufficient.
Sylvester.
Two statements. One is to involve the end user in quality-serve decisions if he wants to be involved. And the other is that help applications. Right. Sorry.
Hold on. Can you repeat that? I didn't quite catch the beginning.
Yep. Involve the end user in quality of service decisions if he wants to be involved.
Service decisions, I think Sylvester said, Wes.
Yeah, quality of service. QS.
And
the other is to help applications to make good measurements, do finger pointing, and getting evidence about the reasons.
And finally, sorry. Finally, Wes, you can cut and paste Ahmed's contribution from the chat window. You've got that there.
I was just waiting to paste it. I couldn't take the time between typing. Okay.
Right, got it.
So okay. Was that the end of the queue?
That is the end of the queue.
No.
Okay. Oh, sorry, Vesna. She got in. She got in just before me.
Yes.
Yeah, don't leave her out. That'd
Just
be bad.
before the questionable ones, so you can also add it to the next one if you want. This is the statement. For the future-proof networking, measuring ecological impact of materials and energy usage is as important as measuring the quality.
Okay,
Thank you
well,
very
there's
much
another-
for that one. I actually meant to poke on that subject because I don't think we've covered it enough. So that's an incredibly important topic that I think we need to consider. So thank you. All right. So the next step that I wanted to do is there anything in this list that is now too small for you all to read that you think is just absolutely wrong, or you think that at least that you think that multiple people agree with you that it's absolutely wrong? I'm just trying to get a feel for which ones are there disagreements out that these conclusions need more work on. And I'm not going to write anything down. I'm only going to mark sort of the ones that people find contention with. But if you think you're in the minority, you know, please don't speak up. Think about the 3 days worth of conversation when you're trying to decide.
So shall I speak? Or are we queuing?
Jeff, we're queuing.
We're
Jeff?
queuing? Okay. Dave, you seem to have, oh no, let me understand where this queue started now. I'm going to go back to where Al said plus Q at 3:12 my time. God, it's early in the morning. So Al, is this in response to Wes's comments?
Thank you, Jeff. No, I was trying to queue up for an additional point, and I didn't see you close the queue in the midst of Ahmed's blast of additional text. So I apologize for that.
No problem. I'll move down. I'm on to Evgeny.
Thank you. Well, I cannot agree with the first statement, and I think that the statement 13 is much better and much clearer. First of all, because currently Wi-Fi 7 targets at latency, and Wi-Fi 7 targets on real-time support of real-time applications. So it means that Wi-Fi developers at least understand that latency is important. So statement 13 will be much close to reality, I think. Thank you.
Thank you. Dave.
Okay, obviously I would disagree pretty strongly with number 2 and number 1. And in the chat, Sam of Sam Knows demonstrated 16 seconds of buffer bloat in his connection and how useless it was. So I believe that anyone that cares to look knows it exists. And as for other studies, I love what Matt just did with the responsiveness metric. So I don't know what constitutes uncontrovertible evidence besides seeing a difference between a buffer bloated universe and a non-buffer bloated one. I don't know how to get from point A to point B there. That's it for now.
Okay, thank you. Roberto.
You're going to hear me say something very similar. I believe we do have incontrovertible evidence for whatever definition you want to use for incontrovertible, that buffer bloat is a prevalent problem. And I believe that we can show that latency is more important than bandwidth in a number of applications. Whether or not that would persuade people is a different question. But part of that is, I understand that points 1 and 2 may be talking to what we can do to convince people, which is potentially orthogonal from whether or not there is evidence.
Okay, so let me do a point of order because we don't have time to debate all of these. What I'm looking for is actually not the ones that I've marked in italics that we do have problems with. I think we've now concluded there's multiple people with issues with 1 and 2. So those are things we need to work on. We're not going to work on them now. So if you're going to speak to one that is not yet been talked about as something that you have problems with. We're just trying to find what's good and what's agreed upon and what's not at this point. What goes into future work.
Okay, given that, Jonathan, still in the queue, still got a comment?
Yeah, it was 1 and 2, and I was just going to say evidence exists at DSL reports as well as Sam Knows and in my own fleet. That's pretty widespread. That's it.
Okay, Ahmed.
So 1 and 2 are off the table.
Can't hear you, Ahmed. I'm going to move
Hello,
on.
can you hear me?
Yeah, now, yes.
Can you hear me?
Yes.
Is it possible to develop a minimum spec for a standard home Wi-Fi router from a network engineering point of view, not spectrum point of view?
A minimum spec
Repeat
for
in
a
the chat
home
window,
Wi-Fi
you're again
router.
having a really, really bad audio. I couldn't understand it.
A minimum spec for a home Wi-Fi router from a consumer point of view is what I heard.
Okay, so that sounds like a proposal to add.
And that will include clock speeds, queue lengths, all that.
Ahmed, your audio just doesn't work at all, unfortunately. It's very broken. Can you paste what you want into the chat? But I think you're proposing to add a new one, not talking about a current one. So please clarify that in chat as well.
Meanwhile, I will move on. Bob, other than 1 and 2, I think is the current working framework.
Yep. Number 10, it's just I don't, I think it needs some more exposition as to what it means. It's possibly true, but it depends what this space is as well, and you know, I don't really know what it's saying. I mean, if it's talking about latency, I would have thought incentives are aligned because it's not a zero-sum game, but I don't really know.
I can give you an example, Bob, since this is my line.
Yeah.
Since we just heard about buffer bloat again, I think we understand buffer bloat very well for 10 years now, right? But the incentives aren't there to get the mitigation technologies deployed at scale.
Yeah, okay. So I just think it's controversial because if the incentives aren't there, I mean, if users don't want it, that's where the incentives come from.
Users want it, but users are not in a position to deploy it where it's needed, everywhere where it's needed.
Right.
All right, so why don't we take this discussion to the mailing list about rewording it in a way that everybody does agree on?
Yeah. Jim. Jim, you're muted.
Oh, yeah. When I first ran into what we now call buffer bloat, I was talking with Dave Clark, and he said something that echoed with me, which needs to come through in our conclusions. And that is, be careful about yelling fire in the theater before the exits are marked. I believe we now have the technology that we've marked the exits. We need to yell fire.
Okay, we were after points that were or were not controversial in that rest of the list. So with that in mind, Jana, sorry. You're muted.
I dequeued myself, I'm sorry.
Oh, you dequeued yourself, right. Turles? Now you dequeued yourself as well. I'm still moving down. Al.
Thanks, Jeff. I like Michael's 15. We need to measurement to be continuous, but I think we need to extend it. It needs to include reliability measurement or connectivity measurement, and that's the only reason to measure continuously. Otherwise, it's an internet of measurements. But thanks for getting that. Thanks for getting that point in, Michael. I missed the cue in order to do it.
Thanks, Al. Omar.
I think that point 17 needs to be clarified because I think that I intuitively agree with that, but I believe it should be reworded. Maybe not now, but I think that this statement can be made clearer. Thank you.
I'll try.
Yeah, we can handle rewording on these. I will paste these all to the mailing list after we're done, of course.
Okay, Christoph.
I wanted to speak to points 6 and 7 actually on the localization part. I don't think that measurement absolutely needs to support localization. Localization is needed to fix a problem, that's right. But in order to quantify and measure a network quality, it is not necessary. And also localization is usually is an entirely different task from measuring it and requires different tools, actually. Having tried to localize buffer bloat here at Apple Park, it's very different from measuring it, the effect of buffer bloat itself.
I may have transcribed that one poorly. I think 6 and 7 were actually almost, similar things reported. I would rephrase based on what you've said to the measurements need to support reporting localization in order to find problems. Right, and that actually sort of merges with 7 then.
Okay, Dave, I did know you'd like to talk later at length on something in response to the chat, but you had something else in mind in the queue, right?
Yes, I did.
Thank you.
Actually, when I first heard them say localization, I jumped for joy because if you go to Google Trends for my bête noire, you'll find that it's only in English-speaking countries. And yet I know from having lived in a Spanish-speaking country that they didn't get it. It just didn't. And they still have horrifically horrible problems. So somehow the word localization meant to me needs to be explained in all the core languages in the world where it needs to go. And we just changed it back. So just my thought, we need to get it out of English somehow.
Okay. Alex.
I have a comment to a few of those, particularly I think we need to separate concerns. I think some of these items are conflating things and I would separate them out. An example is actually number 11, which was, where was the one with the active measurement and passive measurements? And it said basically we need a combination of them. I think these needs to be articulated as, yeah, both have their place. We need to have both, but it does not necessarily have to be a combination. Similarly, in the number 21, the future proof networking, the ecological impact, and is as important as quality. I'm not sure why we are conflating them. I would simply say this is important as well, right? Both are quality is important. And energy usage, those things are important as well, but I don't know why we are mixing them up into a single one. And then finally, the third one was actually what Dave was just mentioning. I think actually clearly localization, isolation is very important, but I would separate that from detection. And I think, again, both have their place. Of course, we need one. Well, maybe we need both, but we should look at them separately. So I would call them out separately. Isolation, one thing, and detection, another thing. Both have their place.
Okay. You up to date now, Wes?
Now we'll reword that one later on the fly. I think that's a good point, but we're already rewording that one twice as it is. So.
Okay, Michael.
Okay, well, thanks for putting mine in. It wasn't really how I would have phrased it. So my point about these continuous measurements was that they need to be queryable after the fact. You're using an application, you want to be able to go back to it. And a part of my point was that that can be done reasonably when you use passive measurements. I am a little worried with just saying measurements need to be continuous because somebody was just saying that then we have an internet of measurements. I mean, we end up filling the network with traffic. So maybe this should have a word of in 14 it is to say that at least passive measurements to be continuous, or passive, or just say passive measurements to be continuous. No, this is in 14. And then the reliability connectivity aspect. I mean, I'm not saying this is not important, but that's not what I would have. I mean, it can include anything, Like my concern would have been pinpointing the reasons for latency. So I would honestly remove that bit because I think it can include various things, and as long as we don't fill the network with unnecessary measurement traffic actively, I think we can measure all kinds of things.
Which one were you referring to? I apologize. I followed your conversation.
The end that was added to 14 include reliability connectivity measures. I'm not saying they're not important. That is as important as many, but I mean, then we can make a long list of all kinds of measures that would be important.
Okay.
Thanks.
I will remove them again.
Yeah, I suspect that other people are going to disagree with you. So reliability is what you disagree with. But
Well, I don't disagree with. I mean, we can add it. We can keep it in. It doesn't matter. I just don't think it's necessary.
I'll mark it for consideration later.
Before I end, I would also demand an explanation of better bandwidth before we just leave that in, because I think better bandwidth in 0.8 is a bit. It's like, what is that supposed to mean? We need to have better.
It's subjective. We haven't figured out how to measure better yet. That's why we're here, right?
Yes, but then, I mean, how useful is that statement then?
Because it's a goal. It's not an implementation. I get your point.
Yeah, but if the goal is as unintelligible as that, then but okay.
Right, moving on. Stuart.
I just want to add my voice to support what others have said about 0.6. I think as it's worded now, it's too strong. The measurement needs to support reporting localization. I think that is an unreasonable bar, because I think it is useful to have a tool for end users to measure the quality of their connection. That needs to be complemented with a whole different set of other tools that the engineers then go and use to find out why the problem is happening. But to dismiss a test because it doesn't have all the diagnostic capability, I think would be a mistake. My other comment, let's avoid using the word localization. Talk about reporting the location of the problem, because localization is often used to mean translating a user interface into multiple languages, and I don't think that's what we're talking about here.
All right, thanks. I've marked 6 as off the table because I think we could rat hole into the wording on that one. I think that there's important elements in that people agree with. We just need to figure out how to state it more properly, and let's do that on the list and in the report later.
Okay, but just before I move to Bob, I wanted to check with you, Wes, as a time check. We've got 30 minutes to go, so
let's cut the rest of the queue. So we'll cut the queue here. But let's run through it.
I'm about to type queue closed, everyone.
Just did.
Thank you. Okay, Bob.
Yeah, just helping Michael with number 14 again. Well, I wrote it and maybe badly. I agree with what he said. And maybe the point here is that metrics like latency, reliability, and connectivity are all intermittent, and so you need to be measuring things continuously in order to find them. And so we need passive. You can take passive out of parentheses if you want. And Michael also wanted it to say continuous and archivable or something like,
yeah, I mean, queryable after the fact.
Queryable, yeah.
Queryable after use.
Okay, thank you. Al?
Yeah.
Thanks, Jeff. And yeah, Michael, I didn't, sorry I had to jump on your particular thing here, but it was this person who said, we don't want an internet of measurements. That was me both times. So we've taken, I think a lot of people have actually taken a look at using active measurements to assess in a continuous way the connectivity and so forth. It just has to be a really low bit rate stream, and there's ways around this, and completely agree with the additional points you made. Thank you.
All right.
Thomas?
So I really liked 6 before. I think it became conflated with that second bullet point. I'm not sure who added that, this English stuff. But I mean, as far as Stuart's mentioning was that, how about, needs to support problem pinpointing, right? Instead of localization, right? I think.
Yeah, there's definitely 2 things integrated into 6, and we need to address that later. You're absolutely right.
Okay, with that, Gori.
I didn't get the difference between 8 and 17. I thought one was going to be about metrics and the other was going to be about kind of future direction.
They're 2 halves of a similar idea. You're absolutely right. I noticed that when I wrote it, but we'll leave them in there for now, and we'll maybe combine them later. I can move them around.
So I'll push for something on saying we need better metrics for something somewhere, but you can figure out how.
Okay, and finally, Anna.
Yes, if we're on the wording, I think the wording on number 3 is also a bit strange. I think I know what we're trying to say, but new measurements, I guess if TCP headers are available in some network, there's no reason you couldn't measure there. I think the intent is that the new measurement techniques or...
How about we not rely only on TCP headers? Is that a better way? I mean, because I agree with you, right? We don't want to say you can't use TCP headers ever again. That's not, that doesn't seem like the right thing.
Okay, we're at the end of the queue again here, Wes.
All right. So in that case, we're going to go on to the next step. So I will send this all out later. We can fight over wording and things like that. I do find it interesting that out of 21, we didn't strike out too many. That's actually a good mark to me. I was thinking it would be possibly more contentious than that. And there's certainly some problems with some of them, and that's to be expected, and that's okay. So the next steps are really, we're wrapping up an IAB workshop, right, with the goals of where do we need to go from here? What, you know, obviously there's a lot of work in this space. The conversations have been nonstop for 3 days, which has been fantastic. Each day there was at least an hour of conversation afterwards, plus Slack conversations and things like that. So in my opinion, there's sort of 2 different things that we can take away from this, right? We have some short-term goals. What do we want to accomplish in the immediate future? And then what are the longer-term goals, things that, you know, we really can't do without significant more reframing. So this is, you know, your opportunity to jump in the queue to figure out, you know, what we need to do. The one thing that we have to do is we have to do a workshop report. That's sort of, you know, mandatory for IAB workshops, and the program committee can, you know, work on putting that together based on the notes that we have taken over the past 3 days, as well as looking at the recording again and everything else to try, and the conclusions list to try and come up with some stuff that we can stay as what we did in the workshop. It won't necessarily be a definitive set of conclusions, but it'll at least record, you know, what the workshop did. But is there immediate work that can be done in the IETF? Is there ideas that people have come up with in the last few days that can be done in either an existing working group or a future working group? And of course, you know, long-term goals, is there future research that can be done? Or I think industry outreach and reach out to end users and other things to help, you know, maybe get a broader perspective would be good. And then unfortunately, I put deployment under a longer term goal because we know how long it takes to, you know, replace CPE environments and replace even OS updates, although those are beginning to get a little bit more automatic, hopefully. But so thinking about all of those, what are your guys' thoughts on where should we go from here?
Okay, Charles has some thoughts.
Like automating getting away of the mute button. So I think I would love first to see that we, you know, finish up with a way to organize ourselves going forward, so that everything that falls over in our timeline today can be done there. And to that end, I would think that the mailing list might be converted into one that doesn't say workshop anymore, but, you know, that would be a non-working group mailing list under IAB thingy. Sponsorship, and that should be open, of course, then. And I think the second most useful tool I've seen in something like the design teams was just to try to figure out how we get ourselves organized on the wiki, right? Could, you know, different topics could get different pages. People who are interested in them would start to collect the information beyond that, you know, initial first page, which obviously would be the points from the last slide. And that, I think, is how far I think organizationally we might want to go. I think at the point in time when the mailing list sees enough interest in any individual subtopic that might, you know, cause another, you know, just interim meeting or something like that. So that's organizationally.
Okay, Dave.
Oh, one point of order, if I could interject, Jeff.
Sorry.
I'm going to merge sort of the last 2. If you are willing to work on something while you're speaking about, you know, things that should be done, please do say how you would contribute. Would you be, you know, an editor? Would you contribute in the discussion or things like that? Just so we get a feel for the interest level among the community.
Okay, Dave.
Important to me are what kind of deadlines that we have ahead of us. There's a group of us here that are working on the BITAG report on internet latency explained, and some of this ties together, but the workload is enormous. So when do you need a workshop report by?
We don't have hard deadlines. It typically takes a couple of months, to get something out, and it's not an exhaustive report. If other IAB members want to step in and give their opinions, that'd be great. But I would say, 6 months or so at the latest would be, my estimate. But it takes a while. It goes through, the typical public comment type stuff. So.
Cool. Well, I would shoot for 3 months and expect 6. That's good. And then what is the IETF definition of immediate?
So badly worded, should we start new work immediately in the IETF? So is there work items that we think, based on the discussions, that, hey, we can actually go work on that now, because there's actually a concrete item that people might want to consider working on.
So one more question, if I may. When will the recordings be published?
My goal is next week, but I have to work with the Secretariat to actually get that done, and it's sort of up to them to go do the editing and extraction and stuff.
So in terms of immediate work, having a bit of chance to review those and rest, and then meeting again as to what could possibly be done would be a good thing to schedule.
Yeah, we can work toward that, or at least discuss on the mailing list.
Vesna.
Hi, I'm a guest to the IETF IAB. I come from the RIPE community, and thanks for allowing me to join. As a community builder, I would like to contribute the cross connections between this workshop and the other communities where I'm active. And as a part of that, I'm inviting you to come to the RIPE meeting, which is virtual. It is going to be end of November, and we do have a working group for measurements. It's called Measurements, Analysis and Tools. So they are looking for contributions right now. So if anybody wants to give a presentation there, you are very welcome. And I will publish kind of a report for our own audiences on the RIPE Labs platform that we have. It will not be as detailed as you are looking for the report. So that's what I want to contribute. And what I'm curious about is how can others contribute? So this is what I would like to hear at the end of this session. I need clarity on, is the list going to be public? Who can create an account on the wiki? Can anybody join Slack? Stuff like that. Thank you.
Good questions. I'm very glad you're here. When you do write up your report for RIPE, please do send it to the mailing list so that we can all see it. But in general, the IETF has a very open group. Anybody can join, efforts to get underway. We'll have to advertise how to create a list, as we may create a new list, as somebody mentioned earlier, where anybody can join, but it's an open group.
Thanks, Wes. Tommy.
Yes. So just talking about the venue for doing work in IETF, certainly we can have a list, but speaking here as the IPPM chair, I think, any immediate work we could do in the IETF would definitely fit within the charter of IPPM. And I think that group of people has a lot of people here. It has the expertise, and bringing in kind of more of this energy into that working group, I think would be quite welcome. So I guess I'd invite any concrete steps to happen there. If we have more researchy steps, that also would fit well in MapRG. So we have places to do this. So it'd be good not to fork efforts and just bring it to IPPM, and that's fine. And in that regard, I would love to contribute, at least in the kind of chairing or figuring out how to shepherd that work into the IETF.
And where's MapRG, Tommy also mentioned. Al.
Thanks, Jeff. I'm turning on my video because this may be my last chance to speak, and I wanted to talk about the same Tommy's topic. Right now, IPPM, we seem to be sort of dominated by the protocol for measurements work, and I would really welcome, you know, a strong thread of the measurements definitions there again as well. I think I had one slide where I tried to really encourage that, and it may mean that we might actually need to kind of segment the work at various places so that we can give each the protocol and the performance metrics definition work adequate attention. And I say that possibly at the expense of my protocol proposal, which is kind of languishing there because of all the other protocols that are really actively adopted and controversial. But I think that's a possibility too. And it might mean I really don't want to split the working group, but I want to be sure we give time for both. And I'm obviously interested to review drafts that show up and work with people on adopting the you know, the templates that we have and making it fit our framework. There's a lot of background there that you know, I can sort of help with. Thanks.
Thanks, Al. Jana, I'm never sure if I'm mangling your name or not, Jana. So Jana, I hope you'll excuse me.
Oh, thank you for actually asking that question. It's Jana, and you weren't mangling my name, although about 50% of the IETF routinely does. I'm used to it. It's all right.
Sorry.
The two quick things I'll note are first, I think that it's useful to consider network quality as broader than just metrics. I understand that the metrics are the way that we understand it and the way we measure it. So even in terms of short-term or long-term goals, I would encourage us to think about this, this particular distinction. And in terms of long-term goals, I would put the same onus on the IAB is about, from my point of view, the IAB and the IAB program is about as broad as it gets. And we are, Bob said earlier that the engineering is in IETF. However, this is not an IETF workshop, it's an IAB workshop. So I'll call out that if we are going to talk about further work, we should be careful to outline what is scoped in here. Most of us are network engineers, and we will try to drive it in particular ways towards metrics and towards measurable outcomes and towards things that we know and we believe strongly, firmly, with all of our burning hearts to be problems. But that's not necessarily how I think an IAB program ought to be.
Thank you. Callum.
So I would love to see some of the people that are here continue some work on defining a metric that could be used in a consumer sense as a way that we describe and sell and rate broadband connections. I mean, basically today broadband connections are largely sold by a imaginary exaggerated version of downlink bandwidth, right? If there was something else that could come into play that started connecting with latency or the type of qualities that we've been talking about here, I think absolutely anything would be a vast improvement over what we have today there. So I think working on that type of thing, focused as this is something consumers can relate to and then sell. Maybe that's RPM, maybe it's something else. I'm not saying what it is, but develop some simple metric in there that gets used for that use case, I think would be very valuable. Thanks.
Thank you. I'm at the bottom of the queue, Wes, so once more.
I think Torles and Gori are in there in the bottom.
Oh, sorry, they came in as my mouth was open. Torles.
Yeah, so I'd support Tommy of saying that, you know, a working group that already exists in IPPM seems to be a good one for the measurement, would be certainly something we should recommend to avoid, you know, creating unnecessary overlap. I think the mailing list would primarily also help with the things that would go beyond what IPPM does, right? And I think that goes to my point from the prior slide of thinking about how to improve the services, which I think we have seen a lot during this workshop, primarily around the buffer bloat. And to that end, I haven't followed all the work on buffer bloat, which seems to be a humongous amount, but is there really the dummies beginner guide draft for, you know, the best things about buffer bloat? Like, you know, we had these point 1 and 2 on the prior slide. and my attempt to improve on that in terms of, what's the evidence, what's the current metrics, to basically highlight the, prevalence and the importance of, the buffer bloat problem to, well, us, the community, but ultimately also those, people that are implementing stuff and are not doing it. Do we have anything like that? If not, then that would be a really good thing to try to get people working on.
Gary.
Hi, I mean, I found it really interesting that we had such a broad range of people here. And it seems fairly clear that the IPPM people can do metrics and do measurements. But I'm not sure that this group of people, even in this workshop, would always be at an IPPM meeting. And when I go, I get a bit fazed by the wide variety of metrics and protocols which are being talked about. So I think there's a kind of challenge here about how we get that message home to the people who need to use this stuff, even in the IETF community. So I suspect there are people in V6 Ops who should know about good metrics for testing networks. And I suspect there are people in transport groups who should know really, like, use this tool as part of your benchmarking, where you come to MapRG, talk about this tool as well. So I think there's a role for the IAB to somehow figure out how to convince all the IETF people that this is important and there are good tools coming, as well as developing the tools. Which really means you've done a great workshop. Thanks very so much.
Thanks, Gary. I've put myself in the queue here. I should note that, I think we're all aware that a huge amount of work doesn't happen in the IETF, and a huge amount of work is orchestrated by other folk. Like Nick McEwen's group at Stanford's done a series of buffer workshops, which have been astonishingly interesting. There's work in protocols. There is all kinds of other work out there. And I think it would be silly if the IETF tried to sort of orchestrate all of this. It's just not going to happen. And the core business of the IETF ultimately is industry standardization for the benefit of everyone. Take technologies and produce standard specifications thereof. So, overreach doesn't really help us. But at the same point, trying to point out where there are architectural issues and actually try and understand them a little more is actually, I think, of value. And that's the kind of the tension that's going on here. In searching for things to do, there's no end to, things that we can do. But in searching for ways that we can complement existing work, just requires a little bit more thought before we go jumping in with new working group or new sets of drafts. So, make haste carefully. Thank you. Anyone else in the queue? Yes, there is. Dave.
Sorry, here I come. So going to the long-term goals, could you strike the word industry from outreach? Outreach is what you both discussed just now. Absolutely, we need to be engaged with RIPE and with the other NANOG organizations and the industry. And is this language that has crept into this debate that bothers me a lot. And it's the word consumer. It's the users of the internet, the netizens, that we're acting on behalf of. And I would just like to strike the word consumer from the conversation entirely, if possible. We use the internet. We do not just consume, we produce.
Thank you. Jim.
I see our biggest problem as exactly this marketing and outreach problem. And that's to both consumers and to so-called consumers, netizens, if Dave prefers, and the technologists both. That they understand the problem, that they understand that it's possible to do something about it, and that they can begin to take action. That doesn't mean there isn't further research. That doesn't mean, I think some statements from the IAB would be very useful, that this, that you can wave in front of people as part of the marketing. Clearly deployment is a big thing, and we wish we had a big win. That's why Dave's and even Vint have been poking at the StarNet people, because a big win would be really useful here. We do need some simple, understandable metrics. And that's what this workshop has been about in large part. You know, the one we've used primarily over time is latency under load, and as defined by the R rule test that's in Toki's wonderful tool. You know, so there are some concrete things we can do. There are some concrete suggestions of where we can start, but those metrics are important because we need to put pressure into the economic system.
Thanks, Jim. I'm mindful of the time. The queue's now closed. We'll go through the remaining two and then I'll hand it back for closing. Roberto.
I realized because of conversation on Slack, etc., that I forgot to bring up a conclusion. It's probably too late, but I just want to put it out there that we see applications using measurement of latencies and things at various different levels, and we've heard that in the metrics. And what's very clear to me is we don't have a good answer for the APIs, even to the applications today, so that the measurements that we're already doing as necessary components of congestion control and things like that can actually be reused. And that is setting up nasty feedback loops or suboptimal feedback loops. I don't know that we want to, I'm not phrasing this in the form of a conclusion because I don't know if we want to add it, but it seems like it is a problem that we don't have a good API for communicating these things upwards.
Thanks, Roberto. And finally, Jana, yours.
Thank you, Jeff. I thought Corey was in queue, but I guess he's not.
Corey was just a comment. Sorry, let me just quickly. It was a comment that MapRG was mentioned when there was concrete work to be done. And Wes, if you're still around or near a keyboard, when you talk about further research, you might put in brackets beside that, MapRG. In other words, you know, there is a group there in the IETF. Back to you, Jana.
Thank you, Jeff. I want to note one thing that I've heard a few times, and I want to challenge us to think about that a little more carefully. Being able to, I found in my experience that being able to demonstrate that a problem exists convincingly to others is not simply a marketing issue. It is an understanding issue. Or differently put, being able to demonstrate that a problem exists convincingly helps us to understand how and where the problem exists much better. So in terms of talking about pretty much anything, I would argue that being able to not just expose metrics, but also be able to demonstrate the problem to people who ask in a way that makes sense to them is super critical. I mean, I'm going to leave it open as to demonstrate to whom, because ultimately that brings in the question of who do you need to incentivize, who are the decision makers, and so on and so forth. I don't think it's a marketing problem. I think it's an understanding of how this ecosystem works.
Thank you. So I think, Wes, it's over to you and the other workshop organizers.
Thank you, Jeff, and thank you for the past 2 hours. And thank you to all of the session chairs in particular that moderated. It's a lot of work to hold a queue for 2 hours and keep your sanity. But the IAB would like to thank all of you for coming. I think this has been a very productive 3 days, and we really, really, really appreciate all the voices and all the work that went into it, both in writing papers in the program committee and to my co-chairs. I'll let Omer close us out, but please, we greatly appreciate all of the thoughts and effort that went into this. It's been a fantastic conversation. Thank you.
Thank you, Wes. Yeah, it has been a great 3 days, and indeed it feels like we're doing something, but indeed it is really just the beginning. Coming up with concrete, useful steps that can incrementally bridge the gap between the consumers who would like things to not be broken and technologists who would like things to be working well is an open problem, and it's open problem with many, 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 many faces. probably it's impossible to solve this at once. And probably it's impossible to solve all of the phases, but we have to start somewhere. And to that degree, I think that we should close this workshop with the understanding that we probably will see each other more in the future, focusing one step at a time. And sure, today we're talking about latency responsiveness. It seems to be sort of relevant. Hopefully in 10 years from now, 5 years from now, we will be talking that we don't need less latency. We only need better latency, right? Hopefully the curve of evolution will continue, and that layer cake of solid, well understood, well communicated, well used properties of the network will get richer and will get people to be able to innovate in the most reckless way while knowing that the network will stand there for them. That's all I have to say. Actually, let me repeat myself. Thanks a lot to everybody here. Thanks a lot to the wonderful members of the TPC. Thanks a lot for the IAB for giving this idea a chance. Thanks a lot for my colleagues at Apple who are trying to move the needle one number at a time. And I think that this is it.
Excellent. All right. I think we'll call this good. Thank you, everybody. And talk to you all soon and right on the list, please.
Thank you.